name of Ganesha. Alright, तर लाईट लॅम्पिंग म्हणजे दीप प्रज्वलन स्टार्ट करण्याच्या आधी सगळ्यांनी सोबत बोलायचे गणपती बाप्पा गणपती बाप्पा. Alright, so let's start with the deep prajwalan. I will like to give a short introduction about the Rainbow Technologies. So we are strategic value added partners for Siemens Digital Industries Software Solutions. We are also value added partners for ZW Software Solutions. Right? So let's start with the light lamping ceremony. So I will call upon guests. Please come on the stage. So first of all, here I would like to call upon for Deep Jyoti ceremony guest. Let's give a huge round of applause to Ranjit Ghorpade sir, who is the Director of Dynamic Robotic and Technologies Private Limited. Next, let's clap for Indrajit Patil sir, who is the Director of Technorhythm Engineering Private Limited. Come on. Next, Tushar Patil sir, who is Design Head Automation Limited. Can we have a big hand? Next is Jaideep Chaugule sir, who is the Director of Shaffer Digital Solutions India Private Limited. Come on, big hand. Next, Sunil Nandedkar sir, who is the Director of Shivam Tech Global Engineering Private Limited. Huge round of applause. Next, Sunil Magar sir, who is the Director of Shinarobo Automation Private Limited. Big hand. And last I would like to call upon Bhanush Gulati sir, who is the Partner Manager for Siemens. Alright, so I request all these guests to please come on the stage and let's start with the light lamping ceremony.
Shubham kurutvam kalyanam arogyam dhanasampadah. Shubham kurutvam kalyanam आरोग्यं धनसम्पदः शत्रुबुद्धि विनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
And closing. So can we have a big round of applause to the founder and director of Rainbow Technologies, Mr. Kishore Nimbore sir. Can we have a big hand?
So welcome all to this excellent evening. So as you already know, Rainbow Technologies was started in 2018 with an aim of delivering technologies and empowering people and to be a part of their journey towards growth. So we are a young dynamic team and ambitious engineers, always ready to learn more and always strive for perfection in whatever we do. So we are the value-added partners for Siemens Digital Industries Software and ZW Soft for their wide range of products. So we support industries across the complete life cycle from design to product validation. Headquartered in Pune, the manufacturing hub of India, we have an active presence in Bangalore, Hyderabad. Talking about our mission to empowering people and becoming part of their journey towards growth by delivering high-end technologies. Our vision to become a leading digital industry software consulting company across the globe. What differentiates us? That are our core values. So integrity, business ethics, transparency, customer delight and respect for individuals. Talking about our milestones, what started as our journey here 8 years down the line, we have started in 2018 with ZW Soft partner. In 2019 we became partner with Siemens. In 2020 we have started our Rainbow Care Center and Rainbow Consultancy and Engineering Services. In 21 we become special partner for Technomatics portfolio. In 22 we have developed in-house virtual commissioning expertise and lab in Moshi, Pune. In 23 we have got Rookie of the Year award at the APAC meet held in Vietnam by Siemens. In 25, we have got the Promising Partner Award of the Year in ZW Soft in Colombo. So, portfolio what we offer is design softwares. So, Siemens CAD/CAM PLM softwares. So, first one is Technomatics, process simulate and plant simulation. Then Solid Edge, all machine design you can do. Siemens NX, Sim Center PLM, and Altair and Sim Center products for simulation. For 2D, ZW CAD, which is an alternative to AutoCAD, a lifetime CAD software. Portfolio 2 is our Rainbow CAD Center. So we have dedicated lab, as I told you, for process simulate in Moshi, and we also provide customized trainings depending on the requirement. Our third portfolio is manufacturing manpower services, where we help companies to the manpower in particularly design and simulation. So these are some of our customers. So all are here. Thank you, sir, for making this happen. So Patil Automation, Park Robotics, Hossein Automation, Shivam Tech, Rulamat Automation, Dynamic Robotics, Innovative Engineering, Pranitra, Suzlon, Park Walls, Virtual Mantech, Unique Robotics, Indwell Technologies, Varade Pactech, Royals Extrusion, ERA Private Limited, Skytech Robotics, Praxian Technologies, IRAS Robotics, M Extend MP Equipments, then Ventec, ProArc Welding, Frontier Automation, RG Automation, AdMax Systems, Niven Mefran, Techira, Shine Robo Automation, Dalwal Flow Control, Clean Energy System, Sigma Engineering, Galaxy, Global Tooling, DNC, Innovative, Technorhythm, Specialty, JJ Engineering, Renault Electronics, Yamatech, Metacast. So these are also, there is list almost. I am proud to say that we have today 500 plus customers. So thank you to all who have supported throughout this journey to us. So this is our good news what happened last year. Our new corporate office, we have taken new office in Bharat Mata Chowk, Moshi. So this is not possible because all of your support and efforts that and trust that you have shown to me when I started. So thank you and hope for more and more. Thank you, sir.
Information. So moving on to forward. Now I would like to call upon on stage from Siemens Altar session. Let's put hands together for Technical Director at Altar, Mr. Sushil Mane sir, who is working as the Technical Director at Altar, and he has been a demonstrated history of working in the engineering, design and simulation field for over 20 plus years on technical engagements with well-known companies in automotive, aerospace and other industries. Can we have a big hand to Mr. Sushil Mane sir?
And Rainbow Technologies for organizing such a wonderful event. We hope to present all the length and breadth of the different solutions that we have at Siemens, and hope to have a very engaging discussion in the evening. So before I would start this presentation, I would like to understand that you're all from the robotics, automation and special purpose machine kind of, let's say, industry, and just wanted to ask whether you have been doing any simulations with various different, let's say, technologies, not just Siemens, but are you using any other, with a raise of hands, if you can just let me know, are you using any simulation tools right now? Can you just raise your hands and let us know whether you are currently using any simulation tools? Okay, just a few of them. Okay, thanks for the response. My presentation today mainly revolves around how do we actually accelerate the performance of different, let's say, complex systems that you are currently designing for, whether it is robotics, complex systems as in automation systems, platforms, as well as special purpose machines. Right? So when you are designing such very complex systems, how can you accelerate the design process, and how you can use some of these simulation and AI tools in the process. So before, let's say, I dive into the main, let's say, products and the different solutions, just wanted to touch base on some of the key trends that we see in the industry. One of the key things that we see is that most of our customers are looking for a very customized product that they want to use, right? Customized as well as flexible in terms of how the product is going to deliver the solution that is expected from it, right? And therefore, when you are looking for such a kind of performance which is customized to yourself, there needs to be so much of, let's say, improvement in the design as well as different, let's say, systems that go into the product which will give you the related custom service that you are expecting from it, right? It is not just a particular mechanical behavior that you are expecting in terms of, let's say, moving a particular product from one particular distance to another distance, right? It is basically looking for some other additional benefit that you are expecting from that product. And it should be very personalized. Right? The second, let's say, main trend that we see is that it has to be smart and connected, right? A product which is so much in terms of smartness is that there is so much of information that is being processed by that particular system, and how you can gain access to that particular data and build AI solutions on top so that you can have much more smartness in terms of delivering the different requirements that you are expecting from that product. Thirdly, of course, this has to be very sustainable in the product that you are designing for. It has to be sustainable. It should not be such that after you have designed and deployed this particular product, it should fail after some time, right? You want that product to sustain for a longer time. And then, of course, it has to be cost effective, right? So there are different, let's say, ways in which you can achieve all these different requirements that a customer is expecting from you. So how you can design such a system? So in order to look at various different solutions that are capable enough to handle such kind of requirements from the customer, I would like to briefly touch upon, let's say, various different solutions that Siemens brings to the table. So if you look at this slide, it basically covers 10 different business lines that Siemens brings to the table. As far as simulation and test solutions are concerned, there are various different softwares which will help you to evaluate the performance in terms of the fluids and thermal, right? So if there is a lot of, let's say, physics that is involving a lot of fluids and thermal, and you want to evaluate the design in terms of how your product is behaving in such a scenario, you can use some of these tools to understand the behavior in terms of fluids and thermal. Mechanical behavior as well, in terms of how the product is performing, whether it is failing for certain duty cycles that you are going to use it for. Also looking at manufacturing, right? So when you are designing this product, how you are going to manufacture that product. And during that manufacturing process, there are going to be, let's say, any issues in manufacturing, right? How you can encounter those issues and then rectify those issues by running these simulations upfront in the design process. A lot of these systems that we are designing for today has a lot of electromagnetics involved in it, right? In terms of, for example, a lot of motors that are going to be deployed in the system, and therefore how you can not only model and simulate the mechanical behavior, but also the motor behavior, and how this interaction between the motors as well as, let's say, all the other electronics that are going to coexist or co-simulate with the mechanical structure. And of course, there are a lot of these other complex systems that you need to model and simulate, and also control the whole system at the same time, right? So when you are looking at not just a single component, but the entire system, and also look at how you can control all the different components at the same time, right? So you need to have a very systems modeling environment, which will help you to model all these different components or systems, and then co-simulate all of them together in the same platform, right? So we have a platform called a system simulation platform. And then apart from that, of course, we have a lot of test technologies which will help you to test the product that you are designing for before you actually launch it. And also at the bottom, if you see, there is a lot of AI that is coming into the picture now. Since almost like 8 to 10 years back, Siemens acquired a lot of different AI technologies which have not only, let's say, looking at various product behaviors, but also looking at very enterprise behaviors that we can capture. And all of this definitely needs data, right? So how you can actually use simulation data as well as test data and then build these predictive AI models which you can then deploy. And the benefit of using these AI models is that while you take so much time to build a CAD model, run simulations, and then check for the performance of the product, you can actually use AI models to do those predictions in a matter of seconds to minutes, right? So it gives you that flexibility to evaluate thousands of designs much faster if you use AI models. So a lot of these AI integrations have now come into place wherein you can actually deploy these AIs in the design process, in the simulation process, or even on your physical systems as well, right? So your physical assets wherein you are actually generating a lot of real-time data coming from sensors, you can actually get those real-time data and then feed it into these AI models which will help you to do predictions. So these broadly classify all the different, let's say, product lines that Siemens brings to the table. So what are these different domains that we cater to? If you look at this slide, it has various different domains that we cater to, right from multiphysics, CFD to mechanical, systems behavior, a lot of, let's say, materials database which is available as part of the platform. We have a lot of new technologies in the form of high frequency electromagnetics as well as low frequency electromagnetics. Fast meshless simulation in the form of a technology which will help you to run these structural simulations much faster without using a mesh, right? And then a lot of AI integrated, let's say, workflows built into the tool as well. So with that brief introduction, I would like to run this agenda, which basically covers some of the key products which are really helpful for designing complex robotic automations as well as special purpose machines. I will delve into the simulation driven design process and what are the tools involved as far as driving the design using simulation, right? A lot of applications involved wherein a lot of customers have deployed some of these simulation driven design tools which will help them to quickly run these simulations much faster and drive the design, right? And then a lot of deployment examples which cater to a lot of systems behavior, right? Wherein we are going to cover what we call as MSN, which is one of the product line which will help you to model the entire system and then look at the behavior of the entire system and how you can optimize the system, right? And then finally discussions and next steps. Okay, so if you look at this slide, we have come a long way, right? From initially using a lot of prototypes that you were building and then testing them to actually moving to a 3D CAD world where you were actually building a 3D CAD and then creating those drawings and then giving it for manufacturing, to a world where we actually started using simulation, right? And therefore, a lot of this simulation was helping us to improve the design now. So if you look at the 2000s or 2010s, wherein a lot of simulation was being used to improve the design and then finally evaluate the design performance, there was a phase where these entire workflows wherein you were creating a design and then using simulation tools to evaluate the performance, it was taking a long time, and therefore a lot of designers wanted simulation to be upfront in the design process at a very early concept stage, right? And therefore in 2010s there was a lot of involvement of driving simulation into the designer workflow. So therein came a platform called as simulation driven design platform, which is what we call as Inspire. And then thereon, of course, there was a great benefit that was achieved by using these tools upfront in the design process so that the overall time as far as design is concerned was reduced. But for the last 10 years, there has been a lot of AI which is coming into the picture, and we are looking at how you can utilize all your simulation data, right? If you are running a lot of simulation, various different simulations, not just structures, but CFD simulations or maybe electromagnetic simulations and so on, to evaluate the performance for all these complex systems, you can actually use the simulation data to build predictive AI models. And therefore, since the last 8 to 10 years, what Siemens has been doing is trying to integrate some of these AI workflows in their design and simulation products. And this is definitely going to benefit moving forward, is because since you take a long time to run simulations, right? When you build a CAD model, you will have to run a lot of, let's say, FE-based simulations, which take a long time for just one particular design. But if you have a predictive AI model, it can actually predict the performance of these designs in just a matter of few seconds. So if you have high quality data available, you can actually build these AI models and then deploy them at various stages in the product development process. So in the last 8 to 10 years, this is the progress that Siemens has been making, of having to combine simulation and AI into a single platform, and customers are definitely benefiting from that. So when we look at some of these complex systems that you are currently, let's say, designing or manufacturing, there is a way in which you can actually look at how to deploy the right way of using some of these design and simulation workflows. And what we feel from the different engagements that we have done in the last 10 to 15 years, the best way is to look at a system performance initially, how you can model the entire system and then evaluate the performance of each of the different components in the system, right? Basically trying to size each of those different components in the system and then drill down to doing 3D physics, right? So initial requirement gathering, doing a functional, let's say, check on the different requirements, do a logical solution element as far as, let's say, the different components in the system. So for all these, we have a platform called as MSIM. And once you have modeled this in this systems modeling platform and evaluate, let's say, the different components in the system and size them better, you can then go down to a more detailed high fidelity simulations. And for that, of course, you can use various 3D physics, whether it is structural simulations or CFD simulations or electromagnetics and so on. So after having evaluated all these different, let's say, physics for your particular system, you can then go down to building those hardwares, right? And especially when a system is very complex, not just structures, but you are also integrating a lot of electronics, there definitely needs to be a lot of check on how it is going to behave when all of these systems are coming together. Not just the structure, but a lot of electronics, a lot of controls and so on. And therefore, we have a platform which will help you to run a lot of these hardware in loop kind of simulations. So once you have made sure that the entire system is performing well, you can then finally deploy it, right? So this is a typical V diagram workflow that we suggest. So before we actually, let's say, delve into that, I thought it is best to start with 3D physics, because you are all coming from a design workflow, right? So as we all know very well, the typical engineering loop that we all see right now is that we start with a design, we get a request for evaluation of that particular design, and then we go to a CE engineer who helps us to model that particular design and run simulations, right? And then he generates these results, and eventually we look at this result and then we see the performance, right? But at the end, if the design is not performing to the expected results, definitely the design is not good, and therefore this loop of having to find out the best design goes on and on till we achieve the final result, right? So this is a very iterative loop of having to design and run simulation and then basically trying to drive a design to an optimum design, right? So in this whole process, we always see that in order to achieve a good design, rarely will you achieve it in the first pass, right? What we are saying is that in most cases, the first pass design is hardly maybe 10%, while if you look at most of the other designs that you go through this entire loop, most of them fail, right? So how you can cut down that? How you can cut down these multiple iterative loops by using simulation? So what is the desired state, right? So the desired state is that we bring in upfront simulation in the concept design stage, run those simulations very quickly in this particular platform, and then reduce the request for multiple prototypes that you actually do, right? So the simulation is done upfront in the design process where you evaluate very quickly using this platform, which is very quick and short. And then once the design passes in this platform, you then release it for building a prototype, right? And once the prototype is built, you then do testing and then go forward. So the whole idea is to bring simulation upfront in the design so that you minimize the multiple loops of design iterations that you typically take. Right? So we have seen by deploying such kind of, let's say, workflows, we are actually able to reduce the overall time required for all these different kinds of simulation, whether it is EMC, mechanical, thermal, and so on. So this is the desired state of having to look at how you can use simulation upfront in the design process and not use later in the design cycle. So in order to, let's say, discuss this further, one of the first products that we wanted to talk about and showcase is what we call as SimSolid. SimCenter SimSolid empowers designers and engineers to analyze the fully featured CAD and keep pace with the design changes without having to compromise on the performance of the design as well as the time, right? So this is a very unique software technology wherein it differentiates from the traditional finite element based simulation tools wherein you don't have to mesh and you don't have to simplify the geometry in order to run the simulation, and that is the uniqueness about this particular tool. We'll see how it is going to help us do that. Right? So what we have here is an industrial forklift system, and we have to analyze that particular forklift system for this load that it is going to carry, and that is of a BIW. So I'll just try to run this video. Can you please click on this video? So if you look at that particular video, it shows you that this forklift has to perform its desired function of having to lift this BIW, and therefore there is this load which is going to come, which is very dynamic. This entire forklift system has various different components, and it has to be modeled with all these different contacts, different seam welds which will help us to connect all those different components together. Now if you come down to this particular platform, the model setup time for SimSolid is just around 12 seconds. The simulation time is just maybe around 29 to 30 seconds. And after running the simulation, we are now able to evaluate the global stiffness as well as the strength of this whole forklift system, right? So this is a very unique platform which will help you to bring in a very complex CAD model that you have built with all those different features that you have modeled it for the entire system. You can bring it into this platform and without having to simplify the CAD and do meshing, SimSolid is able to run these simulations in a matter of just seconds. And that is the uniqueness about this particular tool. So that is a very unique capability which is very different from most of the other traditional finite element technologies out there in the market. So how does that happen in SimSolid is that if you look at this particular system, this system has around 1,180 parts, right? And this entire system has to be brought into the platform, so you can bring in that entire CAD assembly. It takes hardly around 10 seconds in SimSolid to import the model. As far as creating the connections between those multiple components, it hardly takes around 2 minutes in terms of defining contacts, in terms of defining welds, and bolt connections and so on, right? So it is very automatic in defining all these different connections, whether it is seam welds, bolt connections, or contacts. And once you have done that, the analysis setup in terms of defining constraints, different loading conditions, and all that hardly takes around 5 to 7 minutes. And eventually, once you have done all this setup, the whole simulation runtime is just around 30 seconds. So if you add up all that, to run the simulation, it hardly takes around 10 minutes for this complex particular platform. So that is the uniqueness about this particular solution, wherein it actually helps you to simulate at the speed of design. So as and when you start creating newer and newer designs, you can actually evaluate it at that speed. Right? So just to give you a quick overview of what SimSolid can actually do, it is very efficient in understanding the complexity in the CAD, and you don't have to actually start simplifying the CAD. So there is no CAD editing, removing of complex features and all that. It is scalable in the sense that you can actually run these for very complex systems, not just component level, but you can look at different complex assemblies as well. It is very accurate as well. So it is based on, of course, a finite element underlying theory, but it's an extension to FEA, what we call as theory of external approximation, for which you don't have to really mesh, right? So it's a meshless technology which is very unique and very accurate as well. Right? And it is very fast as well. So within a matter of few seconds or minutes, you can get the results from SimSolid. Okay, so what is the solution breadth of SimSolid? So what can it handle? What are the different types of simulations that you can do? So as far as structures is concerned, you can do linear as well as non-linear simulations. So for most of the complex systems that you design and manufacture, of course, a majority of them would be linear static, but there are a lot of dynamics involved, right? So there is a lot of dynamic simulations that you also have to do. And there is, of course, a lot of non-linearity as well. Non-linearity in terms of contacts, in terms of material behavior, as well as large deformations, right? So SimSolid can handle most of these. In terms of dynamics, when you are talking about, let's say, dynamics, it is modal behavior, natural frequencies, right? Or maybe frequency response type of analysis. So you can also do such kind of simulations within SimSolid. And of course, the runtime again is very fast there. You can also do squeaking and rattling. A lot of these systems tend to vibrate, and then when they are vibrating because of the dynamics, there's a lot of squeaking and rattling involved in these complex systems. I'm not just talking about, let's say, robotics or special purpose machines, but even in, let's say, automotive systems, there is a lot of squeaking and rattling that they are interested to model and simulate. So you can also do that in SimSolid. In thermal, you can also do a lot of steady state thermal analysis, as well as transient analysis, which will help you to understand the temperature as well as the thermal behavior of the whole system. And then finally fatigue as well. So you can do a lot of low cycle as well as high cycle fatigue analysis to understand what is the life of the product, or what is the damage in the product when it is undergoing all these complex loads. So a variety of different solution sequences which are available in SimSolid. Since the involvement of SimSolid and then the solution adoption in various different industries, a lot of companies have come forward to evaluate the design, of the complex designs that they design, and see the performance of these designs using SimSolid. And some of these customers have actually given a lot of these case studies, and one such company is JLR. For all these various complex systems that they have designed, whether it is IPS battery frame or maybe chassis metal or shock tower, they have used SimSolid to evaluate. And if you look at the results of SimSolid as compared to FEA, for this first one, the battery frame, the result is almost 3% off as compared to FEA. I mean, the correlation of SimSolid results as compared to FEA is just 3% off. But the time taken by SimSolid is just 1.5 hours as compared to 3 days, which is typically taken in 3D finite element simulations. So it is very fast as compared to FEA. Same again, if you look at the other components over there, it takes hardly 5 to 10 minutes to run these simulations as compared to hours or days in running all those complex systems. So, as I said, said before, it is not just component analysis that it can handle, but a lot of very complex assemblies that it can handle and run simulations. And here is one such example from Serapid, which is a company which manufactures a lot of these material handling systems. And if you look at this particular product, it has close to around 1,000 different parts which are assembled together to perform this functionality of material handling. A lot of chains, a lot of contacts that have to be modeled, and then you run these simulations for various different physics, whether it is static or dynamics. And they were able to achieve the desired performance of this design very quickly in SimSolid. So that was about SimSolid. I would now shift focus to another product which is almost like complementing to SimSolid, and what we call that is Inspire. And the benefit of Inspire is that it is a single platform which will help you to modify a geometry. So if you have, let's say, used a CAD platform to design a particular product, you can import that CAD into Inspire to modify the design. So it has a very CAD set of tools which will help you to modify the design. You can also create designs in Inspire. And then once you have built in that CAD in the Inspire platform, you can actually evaluate the performance of that design either using finite element technology. So there is an underlying finite element solver built into Inspire which will help you to evaluate, or you can also use SimSolid, which is integrated into Inspire, right? And once you evaluate the design for all these different complex loads, you can then think of, let's say, optimizing the design. And therefore, in Inspire, you can optimize the design for, let's say, lightweighting it. If, let's say, weight reduction is one of your criteria, while you also would want to maintain the performance of the design, in Inspire, it will help you to optimize the design. It will help you to do a lot of topology optimization, size and shape optimization, or maybe topography optimization, which will help you to reduce the weight of the component of the system, but at the same time improve the performance of the design, right? So Inspire has a lot of optimization technology built into it, and once you have optimized the design, eventually you would want to manufacture it, right? So even before you manufacture the design, you can actually evaluate the feasibility of manufacturing the design by running different simulations for manufacturing. If this particular component is going to be cast or maybe sheet metal form or maybe injection molded, you can run all these different simulations within this platform, right? So finally you can check for the feasibility of manufacturing, and only if the product is not showing any issues as far as manufacturability is concerned, you can release it for manufacturing, right? So a single platform which will help you to do all this, and that is Inspire. So talking about Inspire, as I said, it has one of the leading topology optimization frameworks built into Inspire in a very user-friendly framework. Many years back, around 35 years back, Altair, which was of course eventually bought over by Siemens, we were one of the leading industrial software technology providers which integrated topology optimization in a simulation platform. And that is one of the unique technologies back then where customers started utilizing this for doing a lot of lightweighting projects to do a lot of weight reduction as well as improve the performance. And that is a technology which is built into Inspire. So if at all, let's say for your complex designs, it is not just evaluating the performance, but you also want to lightweight your designs. So Inspire is a product which will help you to do that. And then of course, apart from doing a lot of lightweighting, you can also do a lot of design explorations. What I mean by design exploration is that you can do a lot of DOE, design of experiments, wherein you can actually modify the design in terms of thickness changes or shape changes, and then see the performance of all these multiple design concepts that you are creating on the fly. So that is also built or integrated into Inspire. And then finally, as I said, Inspire is that platform which will also help you to do manufacturing feasibility. So a range of different feasibility checks that you can do for cast components, metal forming or injection molding or extrusion or additive manufacturing or even polyurethane foaming, right? So all these different manufacturing processes that you would want to actually use it for finally manufacturing it, you can simulate that within the software and evaluate the feasibility of manufacturing and check whether there are issues while you are manufacturing it. Right? And if there are any issues, of course, you can go back into the design and modify the design. Right? So in a single platform, you can get all this. So we got to know what is SimSolid, and then we just went through what is Inspire, which is basically a single platform which will help you to design and optimize the design and check for the feasibility of manufacturing. Now, one of the other leading technologies which is also coming in, as I said, is AI, right? And what we have been doing in the last 4 to 5 years, of course, the technology was built, it was also acquired over the period of 8 to 10 years. But in the last 4 to 5 years, what Siemens has been doing is trying to integrate a lot of these AI models into the engineering workflows. So what I mean by engineering workflows is same like what you saw in Inspire, right? So instead of running simulations, which takes us so much time, right, to build an FE model and run simulations, if you have an AI model, a predictive AI model, you can run that much faster. And that is what one of these technologies is, and that is physics AI. Now, what is physics AI? So just before what is physics AI, just wanted to tell you that a lot of these different workflows that we are engaging in, whether it is in the designer workflow or maybe in the simulation world when you are doing a lot of computer simulations, right? Or maybe manufacturing, right? You can actually use AI to do all this. You can build AI models which will help you to design better, or maybe do a lot of simulations faster, or maybe do the check for feasibility of manufacturing much faster. So what is this technology that we are talking about? It is physics AI. And physics AI is based on a technology called as geometric deep learning. This is based on neural net technology which reads from simulation results that you have done in the past. So if you have done a lot of historical simulations over multiple programs that you have done in the past, you can read those simulation results into this platform called as physics AI, and it will train on those simulation results, the previous simulations that you have done in the past. And once you have a good quality AI model, you can then finally deploy it on the next generation systems that you are designing for. So instead of running simulations for the new designs, you can use AI to do those predictions, right? And that is what this really helps. It learns from the previous simulation data, and then you can deploy it on new designs. So as far as physics AI is concerned, since the deployment of physics AI after having developed this for the last 3 to 4 years, a lot of companies are evaluating physics AI for various different physics. And what I've listed here is just a couple of case studies. Here, for example, Ford is actually using physics AI to do torsion stiffness analysis, for example. And for this example, you'll see that a lot of simulations have been done in the past, right? And when you look at the entire BIW simulations, you run these complex structural simulations. But for example, if your interest is on one such component there, and that is, let's say, this tire tub that you see at the back, at the rear, right? And you want to evaluate that particular design there, that particular component there, you can actually train the AI model from previous simulations that you have done, and then for any design iterations that you want to do on that particular component there, you can use this AI model. And therefore, Ford has actually deployed this AI model to do these predictions, especially to understand the stress behavior, the stiffness of this particular component. And by doing this deployment and trying to understand how AI is helping us to do those predictions, they have gained huge time benefit as well as accuracy in terms of the deployment of the AI model. So it is not just structures, but physics AI can also read in manufacturing simulation, as I said before, right? And in this example here, this is actually a sheet metal formed component. And you can run these simulations in Inspire form, that is what I had presented in the previous slides. And after having done multiple simulations of these forming analysis, you can read all those AI simulation data into physics AI and train that model. And once you train the model, you can then finally deploy that to evaluate new designs, right? So if you look at it, the one on the left is the result computed by AI, and the one on the right is the actual solver. For example, the FE simulations that you do in Inspire. And as you see, the accuracy is quite good. While on the left, the thickness contour, as far as the formed metal component is concerned, is 1.093. It is almost 1.096 in the simulation results. So very close results, but in Physics AI, we were able to do that in just 60 seconds as compared to multiple hours that you would take by running these simulations in any forming simulation tool. So that's the benefit of deploying AI models, and a lot of companies are looking at how to completely reduce the overall product development time by using AI upfront in the design process, right? And then finally, I would like to come to one final solution, which is SimCenter MSSim. And why we are talking about this product today is because for most of these systems that you design, whether it is robotics or automation or these special purpose machines, you will have to actually build the entire system and see the performance of that entire system, right? It is not just component behavior, right? This whole system is going to co-simulate or coexist together, and therefore you need to do a lot of multi-physics simulations, and that is what MSSim helps you to do. Yeah, sure. So I will just run quickly a few case studies which will help you to really understand the benefit of MSSim and how you can use it to do a lot of co-simulation between the system model and real 3D physics. Here is an example of a pick and place robot, and to do such kind of complex system behavior, to understand, okay, what is the power that you need to drive this whole system, what is the motor sizing that you need to do to understand really what is the torque that you need to actually go and pick that particular system, then move that particular robotic system, right? So all these simulations can be done and really understand, okay, what is the vibration in the system, right? So this is a system behavior that you can actually model and simulate within MSSim, and then finally deploy it in a agile kind of framework, hardware in loop kind of framework. So this is going to really benefit in reducing a lot of, let's say, iterations as well as the designing of such complex systems is concerned. And then finally, I would like to also touch base upon two complex, let's say, robotic systems that were actually designed by ABB using our platform. Can you just click on the video? So ABB actually designs and develops these robots, right? And these are almost like pick and place kind of robots again. But there's so much of, let's say, vibration in these systems when you are actually picking these heavy objects, right? And in order to design this whole system better, the robotic system better, you need to model and simulate that in this system environment, and that is MSSim, right? So they were able to actually model this complex system and then understand while you are picking and placing such, let's say, articles, as in this case, a sheet metal here, there is a lot of vibration involved. So how they were able to minimize the vibrations and reduce the fatigue behavior, right? The complex fatigue behavior and improve the fatigue life. They were actually able to do that by using the MSSim platform. So this is a very complex example that was actually modeled and solved by ABB. And then, of course, there is one such last example here before I close. This is coming from Sarcos, which actually builds a full body exoskeleton. And the application is how to actually build such an exoskeleton which will help you to lift heavy weights without having to transfer that load onto the human body. So this exoskeleton is attached to a human body, and while you are trying to move, so that motion is caught by sensors and transferred to that exoskeleton, which will help you to move the entire system and then help lift these heavy objects, right? But in the entire, let's say, process while you are lifting and placing these heavy objects, that load is not transferred to the human body, it goes to the exoskeleton. So Sarcos actually built such exoskeletons, and to do this, the whole, let's say, design and simulation, they were all using MSM platform to do it. So with that, I am nearing to the end of my presentation. What we have to say is that in order to, let's say, design better products, get earlier insights of how the product is going to behave even before you manufacture it, and how you can innovate faster by running a lot of these simulations and improve the design, and then get a greater productivity as far as the whole time reduction or manufacturing is concerned. It is always good to use a simulation platform to run simulations upfront in the design process before you actually manufacture it. So with that, I end my presentation. And before I close, we would like to go through one quiz or questionnaire and have a final, let's say, Q&A. So the question is, what is the Siemens' unique high-speed, high-accuracy 3D structural simulation tool? So this is a question for you. From all these multiple tools that we just discussed, which is that particular unique tool which is a high-speed, high-accuracy 3D structural simulation tool? And the options are MSM, Inspire, SimSolid, or PhysicsAI. So, do you have any answer? The right answer? PhysicsAI. Yeah, you say PhysicsAI. Crossing SimSolid. Anyone else? PhysicsAI. Okay. So the right answer is actually SimSolid. SimSolid is a high-speed, high-accuracy 3D structural simulation tool. It is unique in the sense that MSM is not a 3D structural simulation tool. But if you look at PhysicsAI, PhysicsAI is all based on AI, right? It actually does not do simulations, but it actually predicts on designs. So if you compare the two and the third answer, the second and the third answer, Inspire is based on finite element analysis, right? But SimSolid is actually running it on external approximation technique, which is very high speed and high accurate as compared to Inspire. So the correct answer is SimSolid, and you have given the correct answer. Give a round of applause to
customers in automotive, electronics and semiconductor, consumer products, energy and utilities, medical and pharmaceutical and industrial machinery sectors. Can we have a big round of applause to Mr. Abhishek Sinha, sir?
Good evening, my name is Abhishek Sinha. So I will next, in next about 15-20 minutes, I'll try to cover what is PLM, how do we start, and for the manufacturers, for SME customers, automation, robotics or SKM customers, how do we start? But I'm going to take a step back and I'm going to give you an overview of who we are. So if you look at Siemens as a multinational conglomerate, so we all belong to the digital industry. There are different business units. We belong to the digital industry, and in digital industry we come from the software. This is where we help customers right from design to production, manufacturing, design, simulations, so on and so forth. But what makes us Siemens? Our journey started, it's almost close to 2 decades now, where we have started our journey with CAD, but now with the investment which we have made across technology, a substantial amount of investment that we have made in 2 decades, and the technology we have adopted, we have acquired, that is making us the #1 industrial software in the market. Right from CAD, simulation, data management, manufacturing, this is the whole breadth, and that makes as a combined solution, which is an industrial solution, which makes us the #1 in the market. What also helps us here is with all the acquisition, all the learnings, Siemens, most of you have heard about the name some or the other way. I have seen some switches, some switch gears from Siemens when I was, like 20-30 years back. So So we come from that engineering background, and in that, with that journey, what we have done, our experience in multiple industries, that also comes with that software, that legacy, the knowledge, everything comes right from industrial machineries to automotive to aerospace and defense, and even into the semiconductor business now. So right now, if you look at majority of our customers where we are working with, we see there is a slight change, or these kind of different departments. When you talk about design, manufacturing, services, and manufacturing execution, they are all disconnected. So what we are trying to do is we are trying to bring them together and effective data management. And what that is leading to, there are two major issues. One is the business issues, which you are trying to address as a business owner. The other one, as a head of the department, head of the design, you are trying to address engineering challenges. So these two major challenges which you are trying to avoid, which is making you, losing business to your competitors. You are getting lost, and you are, you are being pushed to cut down your margins. You are increasing your cost in terms of the resources, in terms of your prototyping, and also the global competitive pressures which you are facing. So how do you manage all of this and address all of that? And even today, the products, it is not only about the other two challenges, but the products which you are developing right now, because of the global presence, what India is going after, India becoming, in the initiative Atmanirbhar, we are trying to export. We are trying to also, enhance a product. The product in terms of, enhance the product engineering. You're trying to simplify the processes, your supply chain. You're trying to mitigate all of the risk. All of this is making you again, the product complex and pushing you harder than ever to achieve this. So if you are a design focus, right now, let's say you are just doing design focus, you still have complexity. You are trying to manage your 3D, your 2D, your documents, everything you are trying to do, but in a manual way. Can we solve it? Yes. If you also do multidisciplinary, let's say you are right now doing design, but you do simulation, you do manufacturing. The more and more things you keep on adding, the complexity is increasing. But this is an addressable thing. And how do we address? What are the steps we are going to take? That is what I am going to show you. So what we also did was, we also wanted to understand whether this is one of the problems, whether this problem is only with some set of customers or it is a global kind of thing in India. So we did a survey for about 250 customers, and what came out from the survey was, from 60% of the SME manufacturers today, right now, they say product data management is key component because they are facing challenges. And what they wanted? An integrated platform. Integrated platform means where do you integrate your CAD simulation and do a data management in a holistic way. What we are trying to do is, we are trying to help you make your engineering process efficient and bring a discipline. And how do we do that? So before I give you the overview of our Siemens accelerator portfolio, most of you use Office, and there are many different apps, and you use those apps for particular tasks. Maybe the Word you use, maybe for documenting. Excel you use, your sales would be using, your purchase would be using for cost estimation. Similarly, OneDrive for file collaboration, exchange. Similarly, Siemens comes with a portfolio. It's a recipe for the success. And what does it mean? You have apps. You have Design Center. When you want to do anything for CAD, you have Design Center. If you want to do anything with simulation, you have Sim Center. For data management, you Team Center. The one good part is you can start anywhere with whatever you want. It's not that if you have to go from Design Center to Op Center. You can do the other way around also. It all depends upon your business priority. What is your immediate need? Whether it is design, simulation, data management, whatever, you can start. And that seamless is the recipe to get you to the success. So going back, we will talk about data management. The product which we offer for data management is Team Center. Team Center is widely adopted tool in India across the globe. If I give you a number, close to 70% of the manufacturers who are using a PLM, it is Teamcenter. What makes Teamcenter popular? It is not just the tool which is loved by the customers, but it is also the ease of use. How well it is, integrating with your business processes and your priorities. So we are rated at the very top, but this is not the end. The technical background, the technical strength, what Teamcenter brings here is it creates a digital backbone for you. And what does that mean is, you have right now, we talked about two challenges earlier, that you have business challenges as well as engineering challenges. And why that is happening? Because everything is getting complex, but you are not collaborating. What Teamcenter does, it integrates all the different siloed departments and put together. So now your design can collaborate with the engineering team or the production team or the manufacturing team, everything put together. And what it does, the basic challenge which we are trying to address can be, it is an outcome of it. So you can get the quality, the cost, you can get all of this, the major issues, you can get all of this together with Teamcenter. And how do you deploy it? It's very simple. Either you take on cloud, which is right now everybody is using some or the other cloud solution, personal also like Gmail or some cloud accounts. You can also deploy a hybrid solution where you have a cloud vendor, maybe you can do it with them, or you can do it on premises with your IT infrastructure. So this gives you a very good capability, easy to use, easy to adopt kind of technology. And this is not the end. The other major factor is, because you're from the design, and design being the first part, you may or may not use Siemens CAD solutions. You have different CAD solutions in the market. You will adopt according to your needs. But if you have adopted a non-Siemens CAD, still Teamcenter can integrate. We have customers using various other competitive CAD, still they use Teamcenter as the PLM. That's the industry de facto which has come in for when it comes to managing any kind of data. This is a high level which I wanted to do, because we talked about data management, but that's not the only capability for Teamcenter. When it comes to managing your entire manufacturing, closed loop manufacturing, we can do everything. So what you see here in green, it is all the solutions which is provided by Siemens. The ones which is in pink, it is a third party tool, but still it is what you can integrate with. So let's say you are starting, you start with CAD and you start integrating with Teamcenter for data management. But down the line, you also have something to take care of compliances. You want to, you might be exporting also. So you want to take care of that also. You can integrate that. You can integrate with manufacturing execution system. You can do shop floor automations. All of that is possible. And also what you can do is you can directly push whatever the mechanical bill of material or engineering bill of material you have made directly to ERP. It could be SAP, it could be any other ERP. So Teamcenter is very open in an architecture. If the other third party app, it is not only limited to ERP. You might have developed something on your own, something in-house application which you want to do. Could be on the purchase side, could be on the customer relationship side. You can also do that. So everything is very flexible, and you can integrate that with Teamcenter very easily and effectively. So with this, what happens is the barriers for your product development, efficient product development, gets hit. So with adopting a platform like a Teamcenter, you are connecting your requirement end to end. You are also being able to shorten your design process, make it faster, go to the market faster. You are also improving on your cost. You are making less errors in the bill of materials. All of these can be tackled using PLM. But where do we start? That's the question. I mean, we talked about, this is a good technology, we can adopt, but how do we start? So this is the very starting point. If you take any projects, anything, any project will lead to roughly about 40% of what data you will have is documents. And how do you store? this is the way typically we store. We write something version A, something version B. So that is very, very common and human in nature that we do that, because that's how, and everybody will do it very differently. I mean, no two person will save the document with the same name, same versions. So managing all the documents, be it Excel, PDF, Word, it becomes very, very, very complex. And that's where this comes in very handy, because this is where you want to start. So you start first managing the documents. How do you do it? To adopt easily and smoothly, just like the apps I showed you, like the Word apps I showed you, there are different apps to take care of different features and functions. So the first thing what we are trying to tackle here is the product data management. How are we taking a step to ensure our product are managed properly? When it comes to product, what do you mean? It is design, it could be 2D, 3D, your documents, your bill of material, and the workflows. So if you are able to do this, I think your initial challenges, close to about 60%, is already taken care of. And then you have more different solution as per need, as per business priority you can adopt. It could be manufacturing, it could be change management. We do have change management, but again on the suppliers, manufacturing part, you integrate with cost, quality systems. You can have multiple solutions. But that the first is the crux of the starting point. So what do you get if you say I want to, okay, now I'm ready, that I understand product data management, I want to start, but what will I get from that? So what you get is easy search and navigation. This becomes very critical when you start storing data in a central way. What happens is, let's say you are trying to find a shaft, let's say shaft with 50 millimeter or 50 centimeter of dia or radius. But if you try to search it, it will only search in your local folders, it will only search the file name, not the actual information you are trying to find. This goes inside the document. It will go inside the document and try to find you, let's say, the shaft with 50 millimeter of dia, give me all of that. It will show all the documents that this document has all of this. Which one do you want to choose? You can choose it easily. So that saves time and cost. Second is CAD integration, seamless CAD integration with SolidEdge or NX or any other CAD. So you can do that. Again, I said about document management, you can do that effectively. Then the BOM management. You are eliminating any kind of error. So whatever is revised, let's say it goes through a design iterative process. Some parts will go through multiple revisions, multiple change, and then you know clearly that this is the bill of material, this is the final bill of material which I want to take it and give it to my suppliers. And then again you set up a robust process and workflow to get to the discipline. So this entirely helps you save cost. How it helps is, some of the customers have shared their pain, saying that we have a big design team. They are doing multiple designs, but no two other people are saving it in the same way. And we also don't know in a design organization which one is the latest one. How do we ensure that everybody who is connected knows which is the latest design, so that nobody is reworking on the older one. They have also shared up with us that sometimes we have sent a wrong design for manufacturing, and we come to know only after the product is delivered or when they are doing the prototyping. So these are not only cost but also the time delays which comes in. So the value of the product data management, it enables you and it gives you a single source of truth. So the data which is there you rely upon. You also are simplifying because you are moving fast. We are all moving fast. We don't have time. We want to have simple execution. How do we execute faster? We get projects, we want to execute faster. We do that with adopting PDM and also managing your CAD data and design documents. So in a nutshell, what do you get? You get a centralized storage where you can store all of your data. Then you also get capability of revision and change management. This is where a design which is going through repetitive design iterations, you are able to save time and ensuring that only the latest files are worked upon. Permission based data access, this is also very important, is sometimes not all people need access to all kind of data. So as a business owner, as a design head, you can control who can see what kind of data to ensure that there are no duplicates, there are no redundancy, all of that can be taken. And then you can also do attribute-based data search, which I explained before. And what other thing is you do is workflow-based processes, meaning you bring a discipline system that if there is a design team of 10 members, the designer who is making the initial drawing, it goes to a manager for approval. Once it is approved, then only everybody will see the design. Until and unless it is not released, nobody will see. It can keep on going the iterative process. You can make comments, you can make suggestions, but it will not be released. And what also helps is the IP creation, because for any design, you have gone through multiple round of iterations, and you have understood, you have learned that and from that learning, you capture those learning that let's not make these mistakes again, so that we can save time. So all this IP creation, IP related activities can also be stored. And in this industry, we are seeing a lot of churn. Manpower is also one of the concerns. So how do we address, how do we protect our IP? So that is how you can also protect your IP information and create a knowledge base. So the cherry on the top, Siemens has invested a lot on AI. We are integrating with all the known, the cloud, the AI organization, be it Cloud, be it OpenAI, be it GPT. But we also do a knowledge-based full access, which we give it only to your data, meaning whatever you do, we can build it on top of your data, and that data stays with you. It doesn't go out. So it's not it's not that you will have a risk that your confidential data is being uploaded into an open AI. It is not that you can build something on your own. And then it has Siemens right now, all the solutions has AI features, and there are more which is coming up in the future. Specifically for Teamcenter, what you can do is you have generative AI capabilities where you can interact with your bill of materials, your documents. You can also do a shape search. Let's say I give a 2D image of this remote, and I ask that can you find a similar part which is already being made, designed in the system. It can find it for you, and just by the image you can upload. So all these things is all going and helping you make your engineering processes more efficient. So that's where it comes in. So in an overview, by adopting a PLM or PDM system, what helps you is you can improve your engineering efficiencies by 20 to 30%. When it comes to engineering change cycle time reduction, you can have almost reduced to 20 to 60%. You can improve your bill of material accuracy. You can improve the use of the parts which were already made. You can reuse it for new products, new product development, and also the rework and rejection rate also goes down. So all of these comes to save your time and effort as an engineering organization. So with this, I have a video to showcase from one of our customers who is using our CAD, Solid and Teamcenter, and they have just a highlight of what they've been doing and how they've been using our technology to save time, effort, cost.
Private Limited is amongst the leading wheel manufacturing companies in India and has a large OEM customer base across the globe. Our range of products include for tractors, passenger cars, construction, earth moving, flotation, and implement wheels. We manufacture steel wheels for the smallest tractors to the largest tractors used worldwide. We are Tier 1 supplier to OEMs like Ashok, ITL, Tafe, Hidgin, Acco, etc. Wheels developed by us start from scratch, and thereafter the designing of our tools, tool manufacturing, and then product manufacturing, it is all done in-house.
We have a large portfolio of wheels. We have around 200 wheels that we manufacture as on today, different models. And for these wheels, there are roughly around 350 part numbers, child parts that we manufacture. Now every child part roughly involves around 500 components, 500 tools, pictures, gauges, things like that. And for everything there's always a revision, there's always some documents that are linked to that. So things had started to get out of hand basically at some point in time in the past. So that is when we decided that we should have a solution for effective data management.
Any new product development, our average timeline from concept to serial supplies to customers is 12 to 18 months. During this period, volume of communications exchanged between various departments of both the customer and our company is huge. Our major challenge was to centralize all these communications, customer-wise as well as project-wise.
We evaluated around 4 to 5 other similar solutions from other companies. But when we evaluated Team Center, the best thing we found about Team Center is the integration with other software. For example, Solid Edge, for example, CAN Express, for example, Map if we decide to go for that in future, and other solutions. So we decided to initially go with one licenses of each of these products. And today we have scaled up to 9 licenses from Solid Edge, and we have one CAN Express. We have Team Center, around 10 licenses from Team Center. But now with Team Center, the way it works and the way it improves on the user, that every time he makes a revision, we capture as to what revision is made, how that revision is made, and what are the changes on that revision. All the revision history that is related to it, who was the person who did that revision, why that revision was initiated by, was it by the customer and was it by the quality, was it by the production, was it whatever reason it is all captured.
Team Center has enabled us to seamlessly centralize all these communications, helping us to capture the entire product development cycle at a click of a button.
When drawing is made in 3D, different software is used in 2D or 2D, then somewhere else, some other software maybe for data recording, some other location for document keeping. All this was a normal task, and there were huge chances of mistakes or missing documents or documents not put in properly by some member of the team. Now it is all there, and the mistakes have come down, the data is well placed, we save time because of mistakes that happen from conversion from 3D to 2D, which was earlier done manually. Now it is with the click of 3 buttons, we have the entire drafts ready. There were some tools which used to take a week time for designing activities, reading the 3D, 2D related documents, putting all those places. Now we have a timeline of 2 to 3 days for those same tools. Also, if the tool room people, they should not be having to wait for the design team to come up next day early in the morning, keep running to them, get some details. They can easily search the part from Team Center. So now we are transforming towards digital release of drawing. All the approval matrices are pre-built, and we have a structure where as to which approval will be done at what level, and only after approval it will go to the tool room for manufacturing. CAN Express has also helped us to reduce the timeline of tool manufacturing by 15 to 20%. And we've had saving in terms of machine hours, because machine hours are expensive as well as limited. We always have a large number of tools waiting to be worked upon.
Also, we face difficulties in projecting development timelines. This would sometimes lead to failure in delivery of newly developed products to the customer in time. With all things in one place, we are now able to efficiently project our timeline and deliver as per our commitment. We are now providing first-time right development due to this efficient system. We have increased our total number of developments per year by 18%, hence enhancing our business development capabilities.
Using Team Center and Solid Edge and CAN Express, we've been able to cut down our design time, we've been able to cut down our tool manufacturing time, and obviously because of that we have been able to reduce the delivery time to the customer.
Feasibility of procuring and implementing senior software was one of our financial challenges in our department budgeting. The significant cash outflow was certain, wherein the payback was not very certain at first. Post implementation, we came up with the cost savings at different levels and different departments, and aggregating them all, there were significant savings. For instance, we have reduced 11% of our IT infrastructure cost because of reduced storage of data and multiple backups there. Savings in cost of holding of inventory of tooling reduced by 30% due to proper timeline forecast of running projects.
I cannot imagine today as to how we were working without these solutions earlier. And thinking about those, it just seems like we were in this story.
Many of our customers are also using Team Center and Solitaire. Therefore, being in the same ecosystem was an added advantage. It further added to the confidence of our customers in our capability.
So you heard from one of our customers how they have adopted Team Center along with their CAD and doing the data management to improve their business and making their engineering process efficient. But right now, what we discussed the challenges, we talked about how do we start, but from the Siemens point of view, how do you start there? So if you look at from the overall the licensing perspective, we have on cloud version which is Team Center X. If you want to do on the managed services, if you have an existing cloud vendor, you can do that, or you can also do on your on-prem. What we are also doing just to cater to different kind of customers. Not everyone will need all the features and functionality at the beginning. So what we are doing is we have made different kind of packages. So this will do certain bit of activity, and all of this from essentials to standard to advanced to premium, it has different capabilities. You might not need the latest one at the first time, but you might start something else. And then the other question which is also asked is, if I start somewhere, can I easily go? You can easily jump from different tiers. You start with the very basic, you can move to a standard, because this also, the adoption also takes some time. So you can adopt, you can realize the value, and then go to the second features. So you can keep building on top of that. So just to sum it up, and just to close this and give you the summary which we talked about on the Team Center X point of view, I have just a quick video to give you a detailed idea on that.
Once upon a time, there was a startup that wanted to scale. But Kim, the owner, was overwhelmed by challenges: raising capital, acquiring new customers, deploying an IT infrastructure, and most importantly, trying to optimize and accelerate the design, development, and manufacturing of new products. Then, Kim discovered Siemens Team Center X software. It was packed with powerful tools, which helped her resolve her product lifecycle challenges in one place. Kim and her team could easily organize CAD data, documents, projects, and even collaborate and share with suppliers. The best part was the software was available instantly, pre-configured with industry best practices and solutions to help the business get started with product lifecycle management essentials like design, change, release, and bill of material management. Team Center X was built to grow with the success of her business. Whether it was improving collaboration between teams across her business, enabling her to scale efficiently across locations, integrating solutions to manage product requirements, resources, and schedules, or taking advantage of new technologies like AI, IoT, and virtual reality. Kim achieved all that and more as her business grew. And since Team Center X software was available as a service on a secure modern cloud platform, Kim didn't have to invest in additional IT resources or hardware. Everything worked on her team's existing devices and documents. It just worked, while Siemens took care of the infrastructure, software operations, and maintenance. And her team was guaranteed to always be running the most current version of the software with the latest enhancements. Best of all, Team Center X software freed Kim to focus on growth, business profitability, and market-leading innovation. Learn more at siemens.com/TeamCenterX.
Before I just end, I also have a question to the audience, and Kishore is that we'll have a gift for the one who answers right. So the question is, why is digital traceability becoming critical for industries like automation, robotics, and SPM? The options: A, faster product development, is that the need? Better quality and compliance, is that a need? or reduce rework and manufacturing errors, or all of the above? Thank you so much. I think Kishore. Kishore, you have to give each and everybody because everybody has answered it rightly.
Arre baap re. It's good to know, sir.
Yes, pleasure. Thank you for hearing me. सबने
Then it's the time. All of them.
नहीं सबको दो अगर अभी नहीं गया तो ऑफिस में जाके देंगे थैंक यू सो मच थैंक यू
Thank you so much, Abhishek sir, for the presentation. After this, I would like to call upon stage Krunal Giradkar sir from Siemens Digital Industry Software. Driving growth for Siemens Design Center, portfolio development, solid edge digital transformation, solution positioning and value articulation, accelerating business development for Siemens solid edge and PLM products, industry verticals. Alright, so let's give a big round of applause to Mr. Krunal Giradkar sir. Big hand. Transforming product development.
Right. So I know it's about time for the dinner. I think I'll not take much of time. Next 30 minutes or so, I'll take you through a new probably experience altogether. So starting with the session, we learned about how do we optimize, analyze, and validate the product, right? And Abhishek also talked about how do you manage your data. But then let me talk about how do you create your data, right? Because that is really important. So, hi, my name is Krunal and I'm based out of Pune. I work in a portfolio development team and I'm responsible for design center portfolio, and also been accompanied by Mr. Rahul Varkule, who works as a technical manager for design center portfolio. Okay. So let me start again with the accelerator platform. So this is not any product, right? I mean, this is just a platform. So I mean, how do we define that? It's very simple. It's a combination of software, services, and application development platform. So if I want to break it down, or if I want to just simplify it, so these are the main pillars. So we already know about Team Center, what we have. I mean, how to analyze and validate the product. We already, Abhishek already talked about Team Center and a flagship product and offering, which is a Team Center. And there are two more portfolios, which is Op Center and Technomatics, which actually helps you to automatically shop for things. Probably my colleague Shri Krishna will talk more about it. But a new addition to our portfolio this year is the Design Center. So now exactly what is this Design Center? Okay. So if you could just see, or if I just want to define what Design Center is. So Design Center is nothing but unified platform which helps you to scale or innovate like never before. So these are the three important pillars of Design Center portfolio. First being the uniquely scalable. So what does it mean by uniquely scalable? So it doesn't matter basically if you are a startup or you are an SMB customer or you are an enterprise customer. So we call you all covered. So you can scale from being a small scale to enterprise customer, and as you grow, our portfolio grows, our portfolio helps you to grow. So with 100% data fidelity. Second being the most comprehensive. So combining the power of NX and Solid Edge with value-based licenses, which we're going to talk more about in next few slides. So you get access to right tool at the right time. And finally, the third pillar is the unmatched flexibility. So with industry-focused workflow and strong interoperability, Design Center enables you to or provides flexibility to what today's engineer need. So basically, this is what the Design Center means. So if you are design focused, I mean, if you are an SMB, let's say, if you are a startup, so we have Solid Edge. But if you are growing and then if you getting into multiple things like maybe MCD, mechatronics, automation kind of a thing, then we have NX as a solution. So, but let us talk more about Solid Edge today, and because Solid Edge is a quick run, portable and ready-to-use solution from which you can start your digitalization journey. So let me take you through the intro video and see how our customers are using Solid Edge and building some great products. So now this is really important to understand that Solid is not just an CAD software, it's a portfolio of solutions. So we have solutions for mechanical design, we will talk more about it. We have solutions to cater all your electrical design requirements. We'll also talk about what uniqueness we have to offer. We also have solution for simulation. Of course, we have an entire gamut of product under the scene center, but then what Solid has to offer within inbuilt as a CAD simulation. We have solution for manufacturing. Of course, how do you document your product and then how do you manage your data within Solid. So this is the entire portfolio of the solution and suite what we have. To start with, a lot of time, when I talk with my customers, so even I today, see that customers are facing a lot of challenges while, converting their legacy 2D CAD data. So Solid has some of the great features and functionality to offer, wherein you can just import your, let's say, DXA for DWA drawing, and within a couple of clicks, that drawing can be even exported to the 3D environment. And once that is into the 3D environment, that can be easily converted into the 3D model, a reusable model. So again, very good and very unique and very fast. I would say the way where you can actually reuse your data, right? So like you can see in a short demo video. And also notice, so whatever dimensions you have on that DXA40 file can also be directly imported and those turn into the live dimensions. We call it as a PMI, with the help of which you can actually make changes or edits into the model. Again, a very quick and unique way to reuse your legacy data. So I've tried to capture a few of the highlights what we have within Solid. So if you see the first product, I'm showing there how do you design the part. Of course, we all know, in day in day out we create parts only, right? But what unique we have is the synchronous technology. So does anybody know about synchronous or ever heard or tried to use synchronous technology? Great. It's good to see some folks have already used. So it's a very intuitive and very intelligent way to design your product much more faster and make changes to your design much more faster, make revisions much more faster. Then of course we have a solution for assembly design, but then what unique we have is you can design in context to your parts, so that you do not have to every time go back into the part environment, revalidate the fit and functions, come back, make changes, again validate it. So there and there itself, again with the help of synchronous technology, you can make the changes. Of course, we have synchronous built in the sheet metal environment as well, which helps you to rapidly design your sheet metal components. And of course, we have at the end a dedicated environment for the frame design. How it helps is like once your frame design is completed, within a couple of clicks you can get or extract the bill of materials having cut length and even the total length of the frames, whatever has been used into that assembly. So apart from this, we also have a lot of advanced functionality within Solid. First being the plastic part design. Even if your assemblies or the products have some of the plastic components, so again we have got it all covered and we have those features within the Solid as well. The second video you can see is the the optimization part. So let's see if you have an old design and you want to optimize it and you know that what forces and constraints needs to be applied on that model. So you exactly tell Solid what to do and it will optimize the component for you, which can be later on 3D printed and reused into your assembly. Next we have solution for reverse engineering as well. So again, let it be your legacy data or if you receive any data from your customers which is in the STL format, can easily be imported and can be converted into DREP model, which is the solid model I would say, and can be reused as if within Solid as if it is created in a native product. And then of course we have motion simulation as well. So it's not just the mechanism what we see that how your assembly is performing or moving. It's actually a simulation wherein you can once you complete your assembly, import your assembly, all the relationships gets converted into the real world joints basically. And you can actually simulate the motion and see how does the spaces are getting developed and how it's been behaving. Again, a very good and useful tool just to validate your motions of the assembly before going it or before sending it to the shop floor. So next, let me talk about the model-based definition. Again, this is a very new way that how do you manufacture your product. So traditionally, what we usually do is we create your designs in the 3D software. But then again, to manufacture it on the shop floor, you still print it out, right? You print out all our designs. But what if I can digitally, share that data to my shop floor people? So this is the way, how you can do it. So basically, you can build a template. Template can consist the all kind of different views, maybe section views, cut views, with the PMI live dimension data, could be bill of materials, it could be anything based upon our industry standard. And those template once being created, you just have to select your part or assembly with your sheet metal component, automatically your drafting will get ready, I mean the file will get ready and can be later published as a PDF file, which can later be consumed maybe at the shop floor, maybe on a tab, phone, or maybe even if you have a screens to get into your shop floor, can directly and they can visually directly. So what benefit is it gives, instead of looking at the 2D drawings, you can actually look at into the 3D drawings and see what is happening with my assembly, so that communication becomes much more easier and clearer, right? So that is how we help with the model-based definition. Next, we have solution for piping design as well. So when I say piping design, so if you are into this kit design, right, there are pipes, there are tubes, there are hoses, flexible hoses. So we have solution for that as well. It's not only the 3D piping design. We have a solution for completely building project on starting with your PNID design. And once your project once you're done with your PNID design, that information can be pushed into the 3D environment, where you can actually build the 3D model of your piping with all the fittings and pipe information. And later to that information again can be pushed to create isometric drawing. Again, that is the automated drawing, which later can be used in the field for the pipe assembly or the skid assembly. Again, all the integrated solutions what we have. So let's say if there is any changes or revision into the PNID. So since everything is integrated and connected, all changes should reflect into the 3D as well as into the isometric design. Again, a very unique way to realize that how do you do your piping designs. Next, again, one of the key highlight of the solution, and this is the kind of offering in last couple of years what we had. We call this solution as the design configurator. If I just want to simplify it, it's the design automation tool basically. Now, how many of you have done automation within your software? Maybe some assembly, maybe some parts, right? So you would have used some coding language to do that, right? Build some interface and put in some value in that. Now, what I see when companies do such kind of automation is basically they are not integrated in the first place. Second place, if you want to upgrade your CAD platform, let's say if there is a latest release coming into which is released and you want to upgrade it, you cannot do it, because if you upgrade that software, you need to upgrade all your programming and the coding as well, right? So that is the biggest challenge, and you have to reinvest everything from scratch. So this is the solution which will help you to overcome those difficulties. So what it does basically is it's an inbuilt solution. You just have to build the logic. I mean, you know the logic how the assembly will happen, and there are certain rules available already. You just have to reuse that rules. You have to combine your rules and logic, create one interface where you can just key in some of the, let's say, master dimensions, for example, and every time you make changes into that master dimension, your master file or master assembly will get updated and it will save the newer components. Your part, assembly, sheet metal, even drawings will get updated automatically. So let us take a quick look into the demo, that how does it work. Okay. It's alright. So I just explain it if that's not audible. So this is just an interface. You could see there 1, 2, 3, 4. It's only 4-step process. Wherein in the first step you define what are components are. Second step what are logics are, rules are, and finally if you run that, you can notice here that you just fill the form based upon the dimensions you enter into that form. Automatically your design will update. In this case, you can just see the staircase or maybe the cabinet where the electronic panel what you are doing. You just select how your design should change and it will update automatically. So the benefit what you get here is it's an inbuilt tool, right? So even if you upgrade your solution, your tool, you won't have to worry or bother about what if my if there are certain rules or certain kind of logics are built, and how do I use it? So it will stay with you and it will upgrade it with you. And the best part is with every release we do a lot of changes into that. So you will be always updated. So here also you can see a very good example that how the assembly can be done. You just have to select that how, let's say, in this case, conveyor can be built, you just select it and automatically it will help you to build it. So again, a very, very good way, a very, very advanced way to build and reuse your assemblies and rebuild your assemblies. It's very, very time saving feature. Right, so moving ahead, of course, my colleague talk about the simulation part done, but also we have the flow analysis or flow simulation inbuilt within Solidity. We call it as flow EFD for Solidity. So we basically termed as the front loading CFD. I mean, you won't have to exit Solidity environment, import that file into other environment and rerun the analysis. The environment within itself, wherever you build your parts, probably there and there itself you can create a study, run the analysis. If you feel that it's not working well, or you need to make some changes into your components or assembly, there and there itself you can, with the help of synchronous, you can make changes and you can again rerun the analysis entirely. So again, this is a simple tool. Of course, for complex solutions, you need to scale up to the scene center capability, what just we talked about in the first session. But then, if there are certain quick validations like change in temperature, change in pressure, maybe if you want to check mass flow rate within your equipment, let it be liquid, media could be liquid or air or any kind of chemical, so can be done and quickly validated within solid flow unit. Next, next portfolio solution is the manufacturing. Of course, Shri would be talking more in detail about it, but then I just want to mention that we have all the solutions for your CAM requirement. Let it be starting from 2.5 axis all the way to 5 axis and total machining. We also have solution for 2D nesting. So if you are into the sheet metal fabrication kind of a work and you need the kind of day in day out the requirement of cutting your components from the larger piece of a sheet. So how do you optimize it? So we have got inbuilt solution called as solid 2D nesting, wherein it ensures that the maximum sheet is being utilized and minimum scrap is being generated. Again, and fully integrated with the solid solution. So next part of portfolio is the technical publication. So now we talked about how do you build your data, but then how do you document it? Now, what do I mean by documentation? It means how do you create your installation manual, service manuals, right? Product catalogs. So this is a tool wherein with the help of which you can design or create all those kind of documents. So how does it work is basically, so whatever design or assembly you created within Solidity, import it directly into the technical publications, and you can build the document the way you want to show the instructions, what you can see in the demo. So the best part is, as a part of output file, you can publish it as a PDF or HTML file, which can also be uploaded onto your portals as well. So again, a very, very good way and interactive. Instead of only creating those documents on Word files, Excel file, PowerPoint, which are disconnected and silo solutions, you can use the solution which is inbuilt within Solidity, and you can start creating your digital technical documents basically. Next solution is data management. Of course, Abhishek spoke about it, but that is our flagship solution PLM. But if you are not to that stage as of now, and you want to just manage your CAD data, maybe you want to maintain the uniqueness of document. If you want to prevent the duplicacy of documents, right? If you want to know what is the latest release, latest revision, and those kinds of basics is day in day out what we struggle with, right? If you want to search your files, reuse your files. So this is the quick inbuilt solution. When I say inbuilt solution, this comes and ships completely free of cost within Solidity. So if you have Solidity with you, right from tomorrow you can implement that, and it doesn't take more than half an hour to implement, and you can start working into the managed mode. So what benefit you get is, so let's say if you want to scale up to Team Center platform, your data will always be ready. So that is what you get help with the built-in data management solution. Next is the collaboration tool. We call it as a Team Center Share. Now again, this is a very, very important tool, and again, just to reiterate, it comes absolutely free of cost within Solidity. Now what is this tool? So a lot of time you need to collaborate with your customers, right? So sometimes with your suppliers, vendors, you need to send to and fro your data, validate and take approvals, right? So how do you do that? The second use case could be, a lot of time our own engineers travel to your customer end, right? So how do they access that data? How do they see that data, right? So a lot of time what they do is like, they have to carry the laptop, install Solidity, open the data, right? And again, redo everything there and consume the license. But with this tool, this is the browser-based tool. So like I said, with Solidity you get 500 GB of free space. Then you can upload this data. Once this data is uploaded, let it be, if your engineer is having mobile, tablet, or even laptop, they can just go to Google, go into the link, log in, and they can access data, and they can straight away start consuming data. When I say consuming, what does it mean? So they can rotate, revolve, explode, have a section views, put in comments as well. So when you put comments, that comments can be created as a task. If let's say your customer has suggested some change in your design, so you can put that comment and push that comment to your engineer sitting into your maybe company or maybe your industry, and then that task can be created and will be assigned to that engineer. You can also see here on the screen that there is you get a Kanban style of dashboard where you can see what tasks are created, what is pending, what is the progress being made. So again, a very very good online tool, collaborate within your organization with your or within outside organizations as well. Okay, so just to summarize, we touch base upon all the portfolio solutions, and as I try to capture and show you some highlights. So talk about mechanical design solution and what all do we have advanced thing to offer. I didn't spoke about electrical, but then we have a solution where you can do the 2D schematic, and also that 2D schematic can be integrated with the 3D assembly modeling, where you can do the live wiring design, where you can get all the information from the connections, and you can validate it if the connection is going right or wrong, and you can get it thrown in or cut in within a single click. And then we spoke about simulation, manufacturing, also publication and collaboration tool, which is falls under management. So this is a complete portfolio. I mean, just in summary that what we have as a Solids to offer. So again, to reiterate, it's not just a CAD, it's a portfolio of solution, right? Now next, now we saw that what do we have to offer, but then how do you access it, right? So would you need to buy all of these solutions separately? No. We have a unique way of licensing called as value-based licensing. So how does it work basically? So you need to buy a pool of token, not a license, right? I mean, so let's say if you need 2 or 3, add-on or portfolios or solutions, so you don't need to buy that. You just have to buy token, maybe 25, 50, 100 tokens. Now each and every add-on, like you can see listed here, have certain pool of token, assigned already. Now what happens is, when you get the token, you get to access all of these add-ons simultaneously. You won't have to, buy any of the solution individually. So how does it work? So I try to capture that in a simple slide basically. Let's say there is an organization having 4 CAD licenses, and then they bought a 25 pack of token. Okay, for an example, let's say engineer 1 started some tube routing which consumes 6 tokens. You are left with 19 tokens. Second engineer, let's say 10 o'clock started, let's say normal mode analysis which comes built in within Solids, which consumes again 13 tokens. Now you are only left with 6 tokens. So on and so forth. If you have a pool of token available, you can start and you can use any of the add-on. So add-on could be, all 4 engineers can use the different or separate add-ons, or can simultaneously use the same add-on if you are working on it. And let's say if their work is finished and they close it, so that pool of token goes back to server and again available to use another add-on for another engineer. So it's a never expiring token, valid for 1 year of subscription what you buy for it, but can be used multiple times within 1 year span. Multiple add-ons can be used. So again, a very very flexible way to how do you access it, right? So just to summarize again, these are all the add-ons what you get within value-based licensing, and probably with coming few releases we may add more add-ons to that, so that you won't have to buy any of the individual solutions. You buy the pool of token and you access all of this within that token. So next, let me talk about Design Center X Solids. So now we all know the concept of on-premise software, right? So when I say on-premise means what? The software stays on your system, desktop or laptop. The license stays on your server. Then there is some networking connection is being happening, right? Through LAN or WAN probably, and you pull the license. But if you go outside of that network, then how do you access that license, right? There is no option for that. Or maybe you have to set up some, the VPN connections, right? So, but we address all those challenges with the help of Design Center X Solids, or with the X offering. So let us go through a short intro video and understand what this is, and then we'll talk about it.
Designing today's smarter, more complex products requires powerful computer-aided software. Traditionally, with upfront seat licensing, high-performance workstations, and dedicated IT support, those upfront costs can pose a barrier for many. But Solid Edge X, a revolutionary new addition to the Siemens Accelerator portfolio, changes all that. delivering the power of solid edge in a secure SaaS environment. Solid Edge X offers the industry-leading CAD of Solid Edge and takes it to the next level by integrating cloud-based solutions. With Solid Edge X, you get all the advanced functionalities of Solid Edge with the additional benefits of a cloud-based, flexible, scalable solution, ensuring your design process is always efficient, secure, and up-to-date. Without the need for expensive IT infrastructure upgrades, Siemens delivers, manages, and updates Solid Edge X, so you don't have to, enabling you and your engineers to focus on what you do best, innovate. With enhanced cloud-based collaboration and built-in data management, Solid Edge X ensures your CAD vendor is being handled efficiently and securely. Solid Edge X also offers the ability to scale up your PLM capabilities to Team Center as needs grow. Leveraging the power of artificial intelligence, Solid Edge X delivers AI-powered productivity assistance that provides in-app product help, enabling you to quickly and easily find the information you're looking for, improving efficiency and empowering innovation. But most of all, Solid Edge X offers the flexibility you need to design and innovate like never before. It can be downloaded to your computer with storage in the cloud, allowing you to work offline or on premises, and individual user licenses allow you to access your data wherever, whenever. Paired with value-based licensing, Solid Edge X offers even more flexibility with immediate access to a wide array of add-on products through cost-effective token bundles. A flexible SaaS experience, simplified IT, AI-powered productivity assistance, secure data, and seamless scalability. The powerful design tools of Solid Edge are now in your hands with Solid Edge X from Siemens.
Alright, so if I just want to define it, what Design Center X Solid Edge means. So it's a cloud license. When I say cloud license, so license we manage. I mean, license stays on our server, and the product stays on your system. So basically, it drastically improves the flexibility of how do you use your CAD licenses. So let's say even if you're traveling outside of your company organization, you won't have to get connected to your servers, right? You can just you just get the login. I mean, you get one email ID. I mean, your email ID, password, log in into the Solid Edge, and it will fire it up and you can start using it. And you just need an internet connection just to log in. It's like accessing like how do you access your Gmail probably account, right? And when I say login based licensing, it's the global licenses. So let's say if you buy for example, on-premise license, and if you want to go ahead and use it outside of India, you cannot use it, right? It's the compliances. But if you buy Design Center X Solid Edge license, those are global licenses. Even if you buy it in India, and let's say if your customer is, maybe is there in out of India or on-site, and you want to travel outside of India, you can take your laptop, go log in and start using it. So there is no limitation to that. Another advantage you get is the cloud platform, what I just mentioned. So you also get built-in Team Center X Essential within that, which actually comes free of course with Design Center X Solid Edge. And also you get the AI capabilities. So now let us talk about what AI capabilities you get within Solid Edge. Right. So if you see on the left hand side, so this many years we had a lot of functionalities. For example, synchronous, right? So like for example, we spoke, right? I mean, if you have used synchronous, you would know, or you should actually try to use it at how fast and flexible it is. We also have solutions like predictive user interface. I mean, if you use Solid Edge, it learns the pattern and how to use your commands, and it helps and it suggests you that what next command should be. But then if you see on right hand side, there are few more unique enhancements what we have done as a part of AI. So let us talk about it. So first being the magnetic snap assembly. So a lot of time we struggle with with large assemblies, right? I mean, there are thousands of components, and then for defining the constraints for each and every component, you need to do at least 3, 4, 5 clicks, right? Select the constraint, select the face or edges, could be anything, and then assemble it, right? But what the AI within the magnetic assembly will help you is, you select your reference component, drag it near to your targeted component, automatically assembly will happen, it will fully consume parts for you. Now imagine how much time it will save while working with the large assemblies. So a very very good tool which you can explore and try to get benefit out of it. Next we have AI drawings. So like engineer, our time should get mostly invested in innovating more products, right? But then what we do is a lot of time we we keep on doing the draftings, making it correct, right? Redoing it. So this is where we help you. With AI drawings, basically you just have to select a template, select your part, automatically it will help to create your drawings for you. Probably could be the views, the dimensions, depending on the template what you give it to the AI drawings. And the next is the co-pilot. Let's say if you plan to buy Solidage or if you upgrade and you do not know what are the latest or new commands or how to use it, so you can question it to co-pilot. So it's ChatGPT like feature within Solidage itself and doesn't require any of the internet connection. So you can query your let's say questions into the natural language and it will help you to give you all the help which is required or built in within Solidage. Maybe how do you design these, how do you use this command, where does that command reside, it could be any kind of questions. So again, a good way of learning and reducing the learning curve what we get with Solidage. So probably last thing what I would talk about in the presentation is the NXS essential. So okay, now you understand the concept of on-premise licenses and the design center X, right? On-premise is like everything stays on your system. Design center X Solidage means license you manage, and product stays on your system. But what if you even don't have access to your laptops, right? And if you have tabs or maybe the mobile phones when you travel to your customer place, or if you want to approve or see some designs quickly, on the go if you are traveling. So this is another tool. Again, to reiterate, it comes or ships absolutely free of cost within Solidage with the Design Center X6. So this is not just an viewer what we provide; it's a full-fledged CAD over the cloud. So it works on Google Chrome or Microsoft Edge. Again, how do you access it? You just Google it that NXS Essential, log in with your credentials, with password and email ID, and you get access to full-fledged CAD. So we call it as a browser-based design. And if I want to show you how does it work, so here you can see. So there is a design to get the complete feature tree and also the commands and the sub-options as well. So now imagine a condition you are sitting in front of your customer and customer says that we need to change this, and how do you do that, right? You don't have access to your Solidage, right? So you can quickly log in into your tablet or mobile phone even into the NXS Essential, open your drawing from the Team Center Share, the cloud platform, if you remember what I just spoke about, and you can actually make into changes into the model as if it's a native model, sitting in front of your customer on the go, on the fly, right? And not only the design changes, your assembly, part, sheet metal, and also a drawing can be created within the NXS Essential directly. So when I say browser-based CAD, it's not only it will be able to open Solidage or NX file. It can also open the SolidWorks file, Inventor file, Creo file, even the Step and IGS file as well. So very, very powerful tool. Of course, it gets the AI capabilities what we just saw, and there are many more capabilities what it has to offer as a part of design center, NXS Essential. So of course, Kishore showed some of the great customers, but I would like to again show you some of our esteemed customers, some of the naming Pali Robotics, ACG, using more than 500 of licenses. There is Grindmaster, there is Linox, a lot of customers what we have. Maruti Suzuki, you can not even imagine that Maruti can use Solidage, right? But all their fixturing work has been done within Solidage itself for all their car what they are building today. And we have San Engineering, Daikin, again, kind of a customer, into the consumer product manufacturing. All these is whatever you see for the Daikin is built on Solidage. So, quick question. What is the best way to access multiple products in Design Center Solidage? So, you have to raise your hand and answer it. Okay. Cloud. Okay, who said VBL? Okay, so VBL is the answer. Great. So I think only sir has seen the entire presentation with a good concentration. Alright, so probably since looking at time, we'll take questions at the last. Maybe we have one more session remaining, maybe another 20 minutes, right? So thank you. Maybe we can talk over the dinner as well. So thank you all.
So good evening everyone. So myself Tushar Patil. I'm heading design department in the Patil Automation Limited, and I would like to thank Rainbow Technology to organizing such a wonderful event which is having some insight from the Siemens software. Thank you Siemens as well. So I will start my presentation. So our Party Automation Limited. So we are a listed company. Just now last year we were listed in the NSE Emerge, and we are expanding very rapidly. Basically, we are providing solutions majorly in automation and all divisions. So we have multiple verticals like BIW, welding, then assembly lines, then assembly lines for the military equipment. So these are some areas where we are providing the solutions. We have our presence in these all areas all over in India. We have delivered our projects globally in these countries. Then we have some in-house facilities like AMCs, CNCs and laser cutting machines, plasma cutting machines, which specifically we are using to manufacture our parts to use in our machines, so that we can cater our customers quickly. So I will give you some ideas where we are, how we are using the Siemens software and what we are doing with the software, how we are catering the industry with that software. So first of all, in the powertrain assembly systems, so we have given these lines. You can see this is the PHO assembly line where we are assembling the two-wheeler. So these are some photos of that assembly line. This line is almost 110 meter long, and these all vehicles are assembled on our line. This is the turnkey solution we have provided, and now they are exporting these two-wheelers globally. These are some photos from that assembly line. Everything you are seeing, which we have designed in-house, then we have manufactured in our facility, and then we have assembled, then we have programmed it, then we have dispatched it to customer. So now this is this machine we have supplied to the TACO. This is a very interesting machine because these machines was very precise, and we have manufactured that hydraulic control unit, which is that unit is fitted on the gearbox of Tata Motors. So you can see some photos of that machine. So in this machine we have the facility to cater every operations. Majorly operations we have catered automatically, some operations we have masked parallelly, and there is some pick to lights to assemble that part. Then we have complete traceability solutions. These are some machines we have given to the Maruti for the door assembly line, and you can see some photos of that machine. This line we have provided for the seat assembly. These are some photos of that line for the seat assembly. These are also same photos. Then you can see we have supplied this small line for the assembly of some wheel-led assembly of 4-wheel. Then these are also some photos. So these are the photos of the axle shaft and cylinder assembly line. These are some vision and pick-to-light systems. This is the fuel tank line. That is a small line. Then door panel line. So this is a pipe bending cell. Now going to the electric vehicles. So we have solutions to assemble these battery packs, the motors and all. So recently we have delivered this line which is almost automated. We have only 8 to 9 operators who are working on that line. So we have configuration of 3 4 cell on this line. Then we have the capacity of 3 gigawatt hour, And the beauty of this line is we are delivering the line with the 8.4 second average time of the cell. Then you can see the image. So this complete line we have designed on a solid edge. Then we have simulated this line in simulator software so that we can able to check the cycle time. We can able to check the access. So the every robot and the every machine which is automated, we have simulated first. Then we have make some videos we have shared with the customer so that we can show the customer that how their line will work, and we can verify that. And after that, we have assembled this line, then we have programmed it, and then we have delivered. So this is also a small line for the prismatic cell assembly. Then you can see the commercial machines. This is also some photos. So I have multiple slides, so I am just pushing the slides. These are also some photos of special purpose machine. You can see here that is the fuel tank SPM for the leak testing. We have delivered it to Hero. These are also some small machines. So this is for the overhead gantry we have supplied for the chassis frame handling. This is also one of the overhead gantry. So in a catalytic converter we have some solutions like cell rolling SPM, then linear TIG welding, then cap cutting, then bed flattening machines. Then this is also one solution in canning. So we have given this machine to the Maruti for the canning. So we have solutions in non-automotive as well. So these are some small equipment we are supplied for the solar panel assembly. This is also some solar panel assembly solution we have given. Then about the design and the simulation, we have almost 70 to 75 licenses from the CMAs. And now, as we are expanding rapidly, maybe we will go till 10 to 100 this year. So how solid edge help us? So you can see with the solid edge we can do the faster design. Then that solid edge is easy to use. Then there is having some built-in simulation tool. So that with that tool we can test our machines that whether that force is coming on plate or not, like that in the press machines and all, and we can reduce the cost as well with that. So yes, definitely with the Rainbow Technologies, we are as a partner we are working with them, and they are giving us the best solutions. And these are some future trends in the industry like smart factories, Industry 4.0, then robotic and robots and robots, then some sustainability and green automations, advanced metal handling, then some global chain supply, customization, and the regulatory ethical considerations. These are some major customers who are catering. Thank you.
Thank you so much, sir. So after this, we are honored to welcome Mr. Melin Koshi, sir, who is the design manager at ProArt India with 9+ years of experience in machine design and automation solutions. So let us warmly welcome him as he shares his valuable industry knowledge and practical insights with us for the case study. Also, India's leading manufacturer of CNC plasma and laser cutting machines serving 2,000+ customers globally. Can we have a big hand?
Good evening. वो मेरा टीम में था तो मजबूरी है बोलने का. At least I can have it from you. Good evening. Good evening. I know we are short of time, but I'll try to speed it up. So my name is Melin Koshi. I'm the assistant design manager at ProArt Welding and Cutting Systems India. So I'm here to give a small case study on how solid edge has helped us in this long run. So I'll not explain much. I'll just show a short video about our company.
Born from a belief that world-class engineering can rise from here, from India, where ambition drives industry and innovation shapes progress. Since 1991, ProArc has been shaping the industries. From conventional fabrication to intelligent automation, a legacy built on trust, performance, and partnerships that grow stronger with time.
ProArc was founded in 1991. Indian fabrication industries in those days did not have an Indian manufacturer who truly understood their challenges. That's where we began.
Today, ProArc has a manufacturing capability of over 300 advanced CNC machines every year, precision engineered to endure and built for demanding industrial environments. As the largest manufacturer of powerful CNC plasma cutting machines in India, engineering some of the world's most technologically advanced CNC laser cutting solutions, and building high-precision CNC drilling systems in the industry.
Over the last 35 years, ProArc has grown into leading Indian manufacturer, at the same time evolving into global organization with over 4,000 machines supplied across 5 continents and trusted by more than 2,000 customers worldwide.
When we say built in India, powering the world, it reflects our commitment to combine global technological advancements with Indian manufacturing excellence to build future-ready machines.
ProArc powers industries worldwide with solutions engineered for strength, cutting-edge technology, and intelligent manufacturing solutions.
Our state-of-the-art manufacturing facility has a capacity of producing over 300 advanced CNC machines every year.
ProArc's journey is truly a story of people. From just 2 founding members, we have grown into a strong team of over 200 professionals today. Since day one, our team has been committed to serving customers worldwide with dedication and responsibility.
Machines designed not just to perform, but to endure continuous industrial demands. From India's shop floors to global manufacturing hubs.
As technology continues to evolve, we will keep integrating these advancements into our machines, we'll keep investing in R&D, we'll keep powering industries worldwide, and we'll keep listening closely to our customers to deliver solutions and not just machines.
ProArc continues to engineer progress through solutions built for longevity, performance, and lasting value.
This is where future-ready machines take shape, built through technologically advanced manufacturing and fabrication processes, crafted by skilled hands and tested with advanced equipment to meet global quality standards, keeping our customers ready for tomorrow.
We are ProArc, built in India, powering the world. Born from a belief.
So whatever you have heard is the same thing that's coming up, so I'll just fast forward. So this is just a timeline. So as what you just informed, in 1991 we started the company. In 1996 we incorporated into ProArc Welding and Cutting Systems, and we manufactured our first CNC gas cutting machine. And then in 2011, I just skip it, we are running out of time. In 2011 we supplied our first 3D plasma bezel cutting machine. And in 2014 we exported our first machine to the US. And in 2017 we started our journey with the laser cutting machines. And in 2019 we started with the drilling technologies. And we just shifted ourselves into a new facility in 2024 that we have in our corporate office in Osiri, and the Chakan we have our state-of-the-art manufacturing facility. And in 2026 we have launched our new pipe cutting machine as well. This is a global presence and the service engineers and all the dealers that we have throughout the globe. And this is just to give you the main agenda that we are here today. Just to give you an insight of how many designers we have. We have 10 designers and 5 interns. We have 12 solid licenses and 20 TOD software licenses. This TOD license is mainly used by the production team. So I'll give, the reason I'm here is just to give you a gist of how Solvay has helped us. This is the first case study. This machine we have supplied it to one of our steel mill plate cutting machines in the US. So the machine size is 30 meter length by 11 meter width and 3 meter height. So the total parts in this whole machine was 18,799. So close to 19,000 parts are there in this whole machine, and unique parts of almost 900. So this is how the whole Solage has helped us. There was no, when we say carry both hang over a system, this never happened. And then the simulation, I think in most of the industries, I think in India we could say कि we don't do the simulation thing. It's like sir ने बोला यहाँ पे ट्यूब लगा दे वहाँ पे हो जाएगा, वो bend नहीं होने वाला है. It's out of experience, but we never go into the simulation thing. But then we thought, let's do this. This is a bigger machine, a bigger project, and then that's when almost there was 12-meter gantry. We had done the simulation, we had gotten the results, and the machine is delivered and it's in the US. It's working in the steel mill. It's made in India. It's the same thing that we have supplied a laser cutting machine with the auto loader system in one of the PSU sectors. The whole machine, the sheet metal, everything was designed, completely simulated in Solage. This is another case study. The designers, they usually have, एक झूठ बोलते हैं when a manager comes and tells कि सुबह से शाम तक मैं डिजाइन करता हूँ, कुछ तो बना लेता हूँ, and I think this is the perfect design. फिर मैनेजर बोला ये चेंज करें, पसंद नहीं आया मेरे को, है ना? और हम क्या बोलते हैं? We are ready to change. We are always ready to change. No, we are not ready to change. हमको नहीं पसंद आता जब चेंज करने बोलते हैं, isn't it? But then करना तो पड़ता है, पेमेंट तो आना है ना. But then this is something we are very happy, कहीं कस्टमर आके बोलता है we have this thing in Pro कि कस्टमर आके बोला हमको चेंज चाहिए, हमको चेंज करके देते. But then just imagine the type of stress जो हमको आता है कि अरे चेंज करना है, हमेशा चेंज करते बैठना है. And this software has helped us with something. There is some variable chart that is available, or you can say parametric design that's there. So we just put in the values, the whole thing just recreates itself, and the drafting thing comes, it's updated as well. So this has saved us a lot of time and saved us a lot of designers as well. And this is something, the third thing, unfortunately we had an ERP system inbuilt in our company before we went into the Solage thing. So we couldn't just migrate somewhere outside. Of course, Team Center is there, we are planning to buy that as well. But then we already had an ERP system, अभी कैसे export करें चीजें? ERP को every part needs to be made individually in the ERP, with the names, with the part codes, the drawing numbers. So this is something Solage has helped us with. They have this option of exporting it into Excel with individual names, with the type, with the naming nomenclature we want. So this is something the Solage has helped us with. This is the third case study I can give you. These are a few of the customers that we have. Just skip it. BMW कार खरीद तो सकते हैं, बट इसको सर्विसिंग भी तो करना पड़ता है, और असिस्टेंस भी तो लगता है कि भाई चलाते कैसे. And for us, Rainbow Technologies has been that assistance. Since 2018, they are there with us. In the first, we had only one software, and now we have 12 licenses in Solage and 20 licenses in 2D software as well. That was supported completely by Rainbow Technologies. Kishore sir and Prukul and all, the whole team was there always. Phone नहीं उठाया तो भी they will always call back कि क्या हुआ था सर, आपने call किया था. This is the commitment they have shown with Proarc. So thank you so much the Rainbow Technologies team completely for being with us. And thank you all, very wonderful audience.
Call upon on stage Mr. Sri Krishna Srinivas Pedindi, who is Siemens Digital Industry Software. So the experience is from 13 plus across technology, consulting, sales, business development, project management, vendor management, and process improvement. Can we have a big round of applause to Mr. Sri Krishna Srinivas Pedindi? Thank you. Alright, also I would like to call upon Technical Head, Rainbow Technologies, Mr. Prafulla Patil sir. Can we have a big hand? So, got a 7+ years experience across technology, consulting, sales and business development. Proven track record of building strong customer relationships, delivering customized technical presentations. Can we have a big hand to Mr. Prafulla Patil sir?
Hello everyone, good evening. So it's been a long evening for all of us. First we started with simulation solutions. Next we had a showcase on Team Center. Next we had Design Center. And next we had a couple of case stories that we have seen. I was just observing and I was just speaking with my friend Praful that all of you have been such nice audience. No one is looking at your mobile for the last 2.5 hours, right? So thanks for that. We'll have a short discussion on digital manufacturing. About 20-25 minutes, and lastly we'll have one case story showcase, right? So when we talk about digital manufacturing, I just wanted to highlight to start with some of the challenges or what is the landscape with the customers and with the projects that we handle, right? We see that the customers want, on the left side we have customer expectations, right? Customers want shorter delivery timelines. They want the projects to be more customized, more customization and faster ramp-ups. They want guaranteed performance. And of course, the projects are very, very competitive. The margins are being shrinking. And there is a shortage of skilled manpower for working on these complex projects. On the right side, we see some of the complexities that we see as we maneuver these projects, right? As machine builders, as line builders, we see that every project is now becoming engineered to order project, right? They are more and more customized based on customer requirement. We see that mechanical, electrical and robotics teams work in silos, right? And sequentially, which causes last minute issue identification, lot of rework. We see that factory acceptance test or site acceptance test is most critical, because finally it's what gives us the final approval and the cash flow. There are commissioning risks. There are competitors who are more and more digitally mature. Anything more or any one or two points that you would like to highlight, anyone wants to highlight, which makes your project life cycle more complex? Anyone? Sorry?
Revisions.
Revisions, yes. There are more and more revisions and rework happening from the customer side, right? So that those need to be handled as we progress during the project. Thanks for that. So digital manufacturing is all about transforming from being uncertain to being predictable by leveraging technology. Right? All of us want to be more predictable. So I would like to highlight a couple of examples which we use in our day-to-day life. Right? So compared to our lifestyle, say 20-25 years back, where if I want to go from point A to point B, we used to ask an expert. In Pune, I am new to Pune. If I want to go from Hinjewadi to, say, another location, it was very difficult earlier. Right? Today we use Google Maps. It's become very, very easy. I can predict how much time it takes for my travel. I can see where the traffic is more, where the traffic is less, what are the alternate routes. So that way we are becoming more and more predictable. And if we talk about, all of us are fitness enthusiasts, right? We want to be more fit. And today we have gadgets that we use in our day-to-day life, like fitness rings or smartwatches that we use to track our foot count, 10,000 steps, or for that matter, how my recovery rate has been, how my sleep cycle was. So that way, technology is helping us become more and more aware and more predictable. And digital manufacturing is the tool, the gadget that we use, the Google Maps, the fitness bands, which help you track your progress and be more predictable. That is what digital manufacturing is in the manufacturing ecosystem. Right? So here we have a slide to capture the suite of solutions that Siemens has to offer when we talk about digital manufacturing. On the left side, we have the sequence of processes which any product goes through to come into life, right? We have the planning phase where the assemblies or the parts have to be planned, how and what needs to be manufactured. Next, we have simulation tools where once the planning is done, the feasibility of manufacturing, the feasibility with which the assemblies need to be made, how the products need to be manufactured. So once the planning and simulation is done, we execute those plans on the factory, on the shop floor. We have scheduling solutions, we have solutions where you can monitor the quality. And finally, connecting all the data with your analytics tools. You have various dashboards that you can see where you can monitor the production, where you can take decisions based on these solutions, right? So we have talked about product design using our design center. We have this suite where you take care of new product introductions, design for manufacturability, making sure that you are designing the products that are high on quality, low on cost, and taking care of not only the design and manufacturing, but also the serviceability aspect. Once the products are produced, you need to service the products. Next, we have manufacturing processes that can be managed. So once you decide what needs to be manufactured, next you need to plan how you can bring those products to life. So that is what is planning your manufacturing processes. Planning for parts, we have solutions where you can machine your products. We have something called NXCAM, which helps you in creating efficient tool paths. We have additive manufacturing solutions. Within assembly and disassembly, we have something called process simulation, right? You can simulate and predict how those parts would be assembled, what are the interferences, and various other challenges that you may face on the way. And then, when we talk about a factory or a plant, we have line designing solutions, something called an X line designer, where you can design the production lines. You can do station detailing, you can do simulations. When you go into the actual execution of the projects on the shop floor, we have the MES solutions. We have the scheduling solutions which help you schedule your projects efficiently. Quality solutions which help in tracking the quality of your products, and various analytical solutions. When we talk about product or the factory, you can take data from your factory and feed it back into the system so that you have an efficient digital twin where you can monitor the progress on the shop floor. And not only that, once the product goes onto the field, you can track the various aspects of your machines so that you can take predictive actions for your service. On the top, you see the IT-OT integration, where I'll not go into the detail, but IT systems are all the CAD drawings and various other IT suite of solutions, the ERP and various other solutions that you use. And OT is the machines, the sensors, and we have solutions which can bring these two together in the form of IoT platform so that the communication can happen between the hardware devices on the shop and your IT systems. Finally, we also have supply chain and logistics where you take care of your inventories on the shop floor, what kind of material you need when on the shop floor, your manufacturing and process data management using Team Center and Team Center manufacturing. You have the engineering data management and various other sustainability solutions which help you produce your products using the first time right approach. Right? So now I have given the overview of the digital manufacturing solutions. My friend Praful will talk about process simulate and how it can help you in your project planning.
Hello all. Thank you sir for giving the quick introduction about digital manufacturing. So we will see one of the part of digital manufacturing that can be covered in a process simulate. So first of all, I would like to thank you all the guests and customers to come here and attend this event. And it will be get some delay, but we will, without wasting, I will cover the session. So, what is Process Simulate? So Process Simulate it is a software. There we can do the plan, simulate and validate our shop floor activities. So whatever our robotics and automation activities that we can do on shop floor, that we can early phase of our planning and simulation we can do in with the help of the Process Simulate. So it is generally used in different kind of companies, in manufacturing companies, and global OEMs are using. Yeah. Yes.
Hey, hi. Good evening, everyone. So, hey, teams around, can you listen me? Yes. I think someone is busy in food. So I would request for each and everyone, because I can understand we came from the office, might be we had lunch, and there's a gap. I can understand that. So just good announcement for you guys. People who like drink, we have drinks as well in the house. So I think 15-20 minutes we will maximum take, and within 15-20 minutes we will wind up this session. And I really want to have an interactive session rather than someone is eating, someone is drinking, and someone is listening. I really don't want that. So hope you understand my concern. So team, I'm not disturbing you guys. Whatever जो आप लोग खा रहे हैं आप please खा सकते हैं. But please hold for maximum 10 to 15 minutes. And we have drinks as well. So whosoever wants drinks, hard drinks, you can have. Just give 10 to 15 minutes. Is it okay with you? थोड़ा सा I can understand. I'm sorry. So just 15 minutes दे दीजिए. Thank you so much.
Okay. So it is generally used in a different. They are using by the different OEMs. So all the major OEMs are using this software. So like Tata, Maruti, and Mahindra, and global OEMs also using the same kind of software. So Process Simulate, it is not just about the robotic simulation. So it is a suite of multiple operations, like we can do the robotic simulation as well as assembly simulation, then the human simulation for the economics analysis of operator, and virtual commissioning, that is we can directly connect the PLC with our software, and we can validate whatever our PLC program that can be generated or logic we have created, that we can check with the virtual machine. So we will see the one by one all these topics. So it is a process simulated example. There we can define the different kind of applications, like we can define the kinematics. So in kinematics we can define the movements, whatever we want to do the movements for the different kind of applications, different kind of parts, then the tools and fixtures or other equipment. So we can do the kinematics for them. Then the layout and reachability. So we can get the layout from this software. So we can create a layout as well as we can check the robot reachability and feasibility. Then the collision. So whenever we are running the path, that time we want to check if we will get collide or if we will get fall. We want to check that. So that also can done with the process simulate. Then the assembly sequence. So whatever the sequence we have defined. So as per that sequence we can simulate and validate the program. Then there are the different kind of we create the images, documentations and movies to showcase the customer so how it will be run the entire life. And in robotics we can do the different kind of robotics applications like spot welding, MIG welding, arc welding, laser welding, then the cutting drilling, and also we can do the continuous operations like the painting, sealing, fluid operations, and also it supports for the handling and material handling applications. And in VC, we can do the connect the software with PLCs, CIMIT and remote, that is the hardware part, so we can directly connect processor with those softwares, and we can validate whatever our program. Then we can check the material flow, logic logs, then whatever our IO lists are there, we can map that IO list also in this using the VC. And human simulation, we can check the assembly process, then the ergonomics analysis, and whatever the motion capture, virtual reality, we can do with the human simulation. So in squat welding operations, so if you see right now, there are the multiple things we can do with the process simulation. So one of the part is the spot welding application. So if you want to validate our path, or if you want to all the spot location, it will be reachable or not, that we can validate with the process simulation software. So it can support for the multiple features, and it also supports for the multiple robot brands, and it is having a multiple kind of features are available in process simulation. So we need to just give the path and locations and points to validate the program. So using there are some features like automatic approach angle and geometric gun search. So using the geometric gun search, we can directly add their multiple guns, and software will be suggest that which will be the gun which is suitable for the that particular operation. So that kind of things we can do. Then the safety robot manager we can do. Then the safe falling and collision detections that we can do with the process simulator. And last, the offline robot programming. So it will be get generated offline OLT programming. So it will be help to reduce the production errors and collision, generates ready to use robot programs, and reliable cycle time to get results of whatever we want. Also, we can do the similar like the spot welding, we can do the arc welding, or we can say as the big welding. So that also we can do with the process simulation. So using the arc or MIG tool, we can create a path for the whatever our application. So there we can define the gun, and we can fix whatever our torch, we can validate that torch, and we can use the particular angle of that torch to get our desired results. So also it is support for the 7 axis or external axis, that it is also supported for that. So we can do that also, and we can download the OLT program from the MIG welding or arc welding. Then handling and palletizing. So in handling palletizing, there are like if you having pick and place operation or handling application or palletizing and palletizing. So all these things we can do with the process simulator. So there also we can create a part and define whatever the moments and whatever the required inputs to for that part. So after defining all these things, we can directly generate or validate all the things of and get the our program and all the things. So offline programming. In that offline programming, actually right now we can do with all the robot brands. We can support. It will be support for all the robot brands. So process simulator support for the ABB, KUKA, HANU, then Java, Kawasaki, Panasonic. All the major industrial robots are available market, that all the robot brands will get supported, and we can get the offline programming for that. And for if you see in bottom of the table, there will be the offline, online and optional things. And so if you see there, optional thing will be the, if you having the existing our robot backup, so we can also import that backup into the process unit and validate or recheck the whatever our application will be there. And also the second thing will be the position and motion path, so we can directly locate our path using this process simulate. Then in offline mode also we can define the whatever our robot brand programs are there. So we can define those parameters and the commands we can directly define. Then we can optimize our cycle time and path optimization to get the desired result of our cycle time. Then in optional thing also there will be we can check the signaling and cloning on things we can do with the optional thing. Then calibration, that will be the online stage. So calibration will be done by the online at on-site commissioning. Then we can download the robot program and commissioning for the on-site commissioning. So if you see here, it can be digital tools synchronized with the software, and we can get generate for the program that is standard program. Also, if you are aware about in industry having specific robot brand softwares like for the ABB having their own software, then Hanuk having their own software. So that will be only supported for that particular robot, and it is support for the most of all the robots. And if you see what will be additional benefit is you will not need to require the means actual robot programmer having the experience on that specific having the experience on ABB robot programming. So he will only do the ABB robot programming. He can't do the KUKA, ABB, KUKA, Hanuk or any other robot. But with the process simulate, we can, if you having how to create a program for the single robot like ABB. So similar way, you can directly generate the program for the other robot brands. And means it's not need to create multiple multi-skill or multi-person required for the simulation on offline programming. So single person that can be used for the multiple robots running. Then next will be the cable simulation. So this cable simulation only offers with the process simulation software. So majorly this whatever our on robot, there will be the cable or press type that we can simulate with the process simulate. So there we can check how our cable will be get twist or it will be get collide or how much cable will be required to do the simulation. So that kind of facility will be there. So it is easy to create for the only defining the frames. After defining the frames, it will be cable get created, and also it is showing and analyze how it will be get means get twist or not. Also it supports for the retractable moment. So if you have the retractable moment, so that also it can support for the process simulation. Then next will be the human simulation. So for the human simulation, there are the process simulate support for all the human properties or database available in market or standard database. Like for the human simulation, it will be required a specific human model. Like suppose there will be the German human, so it will be around 6 feet or more than 6 feet height. There will it will be. So like that, there are the standard library available for the Ansu to Chinese to then the Asian, German, Japanese, Korean, and Mexican. So all these human dance, human models or database are available. So we can directly generate human model using this software, and using that we can check our ergonomics or whatever our task or analysis that we need to check. So assembly sequence or whatever the effect on their body or what will be the process we need to do. So that all the things we can do with the process simulator. And in there will be one feature is task simulation builder. So using that we can directly, it's easy to create simple means path for operations using that task simulation builder. So there will be the commands like go, get, put, or if you want to do some simple operations like go, get, put, position, ports, graphs, or similar kind of operation, then we can do the process simulate, and also then get generated different kind of whatever the standard are available in market, so that also gets supported. So these all are the ergonomic standards are available in market. So all those standards are available like OWASP, strain, fatigue, then the Rulan OWASP, then the physics demand, force energy, energy expenditure. So all these are supported. So this is the one slide that is the why choose. We want to choose the process simulate all over the other simulation software. So it is a complete digital manufacturing solution. It's not only for the robotics or any particular application. So it is complete for the digital manufacturing. So in other simulation software is supported for the particular applications. Then the advanced robotic simulation are available. Then offline programming for the multiple robot brands, as I said. Then multiple applications like robotic applications, bot meat, handling applications are there. Then virtual commissioning support. Then multiple robot coordinations are there. Then automatic collision detection are there. Automotive industry uses. So all the, as I said, all the OEMs are majorly using this software. So also having a good presence in global market, and we can directly integrate with our PLM solutions. So it is also supported our integration part that we can do with the process simulating the smart manufacturing and industry 4.0 can be supported. So for the up to this only the covered by the robotics and human simulation and assembly simulation, and remaining part of the virtual commissioning that can be covered by the research. Thank you to everyone for this giving me this opportunity and
We have last 5 minutes where I'll cover the virtual commissioning part. Right. So virtual commissioning is one of the concepts which helps you design your mechanical, electrical, and robotic systems and validate their logic, validate their behavior right at the concept stage before you jump into the commissioning activity. Right? And this is one of the concepts which is becoming more and more adopted by various line builders and in the industry. And OEMs have started asking it as a mandatory requirement. Right? So this is very powerful concept, and we see a lot of traction in this solution, in this value that you can get out of this solution in the market. Right? So this concept can be used in both scenarios, both in greenfield and brownfield projects, where if you look at the life cycle, you have the requirement gathering from your customer, preliminary design, detailed design, commissioning, operations, and retrofit. Right? Right at the design stage, right? At the time when you are gathering the requirements and designing your preliminary, creating your preliminary designs, you can start applying this concept to validate your mechanical behavior, to validate your robotic behavior, automation behavior, right at the concept stage. And you'll be able to be 100% sure of all the behavior before you go into commission. If we talk about the traditional process or the method that we used to use, that is still in practice, is that the mechanical design is generally carried out first, and all the other parts sequentially follow the mechanical design, right? The electrical design is done after the mechanical design is validated, then the robotic programming, then the automation engineering. And finally, when the commissioning is done, all these steps are validated in a sequential fashion, because of which you see that a lot of rework happens at the commissioning stage. because of which there is project delay, there is delay in commitment that you have made to customers, and it also costs a lot of cost in terms of your engagement with the customer, the time you spend on the factory floor while you are debugging the issues. And the modern way or the go-to way is planning your mechanical design, electrical design, robot and automation engineering in parallel. So using your virtual commissioning concept, what you can do is plan all these things parallelly rather than following a waterfall approach where you correct one function, secure one function correctly and then go to the other function. You can follow a agile approach where you go with the concept designing of all these activities in parallel and conduct virtual commissioning, where you validate all your operations, all your PLC logic, all your interconnectivity, all the interdependencies in parallel while you are designing your solution. So that way your commissioning time is reduced because you are confident about your behavior even before the equipment lands on your shop floor. Right, so we have two sides of the story in a traditional way where your mechanical engineers and robotics engineers are concerned about the kinematics, the robot programs, mechanical sequences, layout, and various other aspects. And your electrical and automation team is working on your input-output logic, your interlocks, HMI, diagnostics, safety aspects, and various other things, right? And both these departments can work hand in hand, and through this concept you can test various aspects, various interlocks, various logics in parallel. So here we see, so when we talk about virtual commissioning, there are two concepts again that come into play. One is software in loop and another is hardware in loop. Software in loop is nothing but you have a digital platform, digital twin of your product as you are designing it, and you have the control systems which are also digital. So you do not have any hardware or the control hardware or the PLCs on the shop floor, but you have it in a digital platform. So you can, using the digital controls, validate the operations that happen in a digital way and see how the dependencies and how the bottlenecks can be addressed. And using hardware in loop, once your PLCs and the control hardware is on the shop floor, using the digital environment of your product, you can use the hardware controls to see how the behavior actually would translate in the digital world. Right? So first you did both digital, your control is digital and your performance monitoring that you see is digital, right? And next what you do is you bring in the hardware, you see how the hardware controls the digital world, and finally we have the physical world where the equipment is physically available on your shop floor and digitally you already validated the hardware, the controls, and both of them would work seamlessly because you have tested all the logic and all the controls. So here, so this is an automotive body in white shop where there are a lot of interdependencies, robotics, automation that comes into picture. And we can further fast track it. So first you have software controls and your digital platform looks like this. You can see how the robot would operate, what would be some of the interdependencies or challenges that you can see, right? Any interferences, any logic that is not working the way it should. And you can correct it right at the concept stage. the video you would have seen someone who is using hardware as controls, and he would have a digital world where you would see once you change the controls how the robots would operate in the digital platform. And this can be also used to train your operators, how the logic and behavior would work on your shop floor, and you would do that in the digital world so that you don't spend time and effort once the equipment is commissioned. Right? So here we are showcasing a case story on Wipro Pari, who is using process simulate and also virtual commissioning in their projects to fast track their projects, right? And they are using our software to validate the operations, to predict what are the interdependencies that you would see, to design your mechanical, robotics and automation systems right at the concept stage. And it is helping them in fast tracking the project deliveries, maintaining strong commitment with the customers so that you can be more competitive, because your delivery timelines will be less, you will be spending less time on the shop floor debugging. All the debugging is done in the digital world. So that's the concept all about. And next, Prabhu, if you go to the next slide, we see some of the benefits. 70% reduction in on-site commissioning time that they have achieved in one of their large projects, 50% reduction in rework, assembly line validation end-to-end done within 3 months from project start. And if you go to the next slide, Prabhu, if you go to the next slide. So this is one of the quotes that the Chief Executive Officer of Wipro Pari say about us. They say that with Siemens solution we have significantly improved performance ramp-up and mitigated risks. Right, so more and more line builders are now asking for these solutions because one, the OEM is asking it as a mandatory requirement because they want to reduce risk, they want to fast track the implementation, and two, because it also is saving them cost and effort. Okay, that's all we had to discuss, but happy to get into focus discussions. Please reach out to us. Thank you. Yeah, we have one last question. We have one last question, which comes with a prize, right? Again, please have a show of hand. What is the most expensive place to find a machine issue? We have 4 options. One is the design phase, 2 simulation phase, 3 shop floor commissioning, and 4 operator training. Yes, all? Shop floor commissioning, and that's the right answer. Thank you. Thank you all.
Thank you, sir. Next, I would like to call upon Mr. Ranjit Ghorpade, sir. Over 15 plus years of experience. Alright, before that, I would like to call upon on stage Siemens Digital Industry Software, Dhanush Gulati, sir. Can we have a big hand? Over 12 years of experience in selling a range of products to IT solutions, applications, CAD/CAM software and infrastructure across verticals including business development and key account management. Thank you.
So, I don't know why I'm smiling right now, but I can sense your situation. That's it. I can sense your situation. I'm sorry for that, but I believe, you guys took some information, something which we really want to represent in front of you. I believe, as from my understanding, it is a very wonderful session. Thank you so much, everyone. You took your time after office. You left home. बीवी बच्चों को छोड़ के आए हो आप लोग. I can understand. घर से फोन आ रहा होगा. Thank you again. Thank you very much. So I just want to tell you one thing very clearly. So this is a company named as Rainbow, and we have an honor of Rainbow. So Rainbow is our trustworthy partner in Siemens ecosystem. I forgot to introduce myself. My name is Dhanush Gulati. I work for Siemens. I work as a partner manager in Siemens ecosystem. I sit in Gurgaon. So thank you, Kishore. It is actually a wonderful gathering. and the way you design, it's appreciable. Thank you, Kishore. For any question, for any doubt, anything you want to discuss, you can definitely connect with each and every member from Siemens team, and definitely one showman, Kishore.
And my team.
And your team, yes. Thank you, team. I forgot to add teams because I really want to have. I'm in rush right now. I'm sorry for that. All right. Thank you so much, team. And now this is time so far. This time काफी time से wait कर रहे थे. Just cheers with glasses. Thank you so much. And yeah, our team we really want to capture your presence. So why not आप सब एक बार आप आगे आ जाइए, and we really want to have a photograph with you all. So एक live photo हो जाएगा. So please जो जहाँ पर बैठा है खड़ा है, please एक बार आप आगे आ जाइए.